we are live, sir.
Yeah. So we can start. We can start the just yeah.
Okay. So, respected Chairman Dr. Prasad Bhaskaran, invited speaker Dr. G.A. Ramadas, coordinator Dr. Rohit Srivastava, participants, ladies and gentlemen, a very good morning to all of you. Myself, Dr. Josia from National Institute of Ocean Technology, Chennai. Along with me, Dr. Rohit Srivastava from NCQR. We are the coordinators for the session. Today, we have two most befitting ocean technologists as the chairman and the lead speaker. So we have 11 oral presentations of 15 minutes each. We can have quickly 2 to 3 questions after each presentation. There is a tea break from 11:30 to 11:45. I request all of you to keep the timing. Looking at the details of the participants and the topic, I'm sure we are going to have a very interesting session. So with this, I welcome you all for an exciting session of the Ocean Engineering and Technology session, the 15th technical session of Osicon 2021. With this, I request Dr. Rohit Srivastava to introduce the chairman. Rohit, please.
Thank you, Dr. Josia Joseph. It's my pleasure to introduce Professor Prasad K. Bhaskaran. Professor Prasad K. Bhaskaran did his MSc in Meteorology and Oceanography from Andhra University in 1991 and received University Gold Medal. He received his PhD from Kurukshetra University for his work on atmospheric and oceanic sciences in 1999. He began as a project scientist at Center for Atmospheric Sciences, IIT Delhi in 1998 and in Quest, Hyderabad till 2003. He was a postdoctoral researcher, Novel Research Lab, Louisiana State University, USA from 2003 to 2004. He joined as assistant professor at Indian Institute of Technology, Kharagpur in the Department of Ocean Engineering and Naval Architecture in 2004. Currently, he is serving as a professor in IIT Kharagpur. He has supervised 57 masters, 12 doctoral and 1 postdoctoral research fellows. He is member of Board of Studies at Kerala University of Fisheries and Ocean Studies and Cochin University of Science and Technology, Kerala. His expertise lies in ocean wave modeling, coastal processes, climate change impact on wind waves, port and harbor engineering, physical and dynamical oceanography, sediment transport dynamics, coastal hydrodynamics, tropical cyclone, and coastal engineering. Recently, he was selected as a fellow of Ocean Society of India in the same conference, Osicon 21. With this, I would like to invite Professor Prasad K. Bhaskaran to please chair the session on ocean engineering and technology. Thank you.
Thank you, Rohit Srivastava. So today we have an invited talk from a very eminent scientist, Dr. G.A. Ramadas, the director of NIOT Chennai. So let me introduce the invited speaker of today. Dr. G.A. Ramadas has done his MSc from the Department of Physics, Indian Institute of Technology, Kharagpur in 1986. He obtained his PhD from IIT Madras in 1992. Thereafter, he joined as Senior Research Fellow at IIT Madras in 1992. He began his career as a scientist at NIOT in 1994 and rose to the highest position as director of NIOT Chennai. His expertise is in the areas of manned and unmanned underwater vehicles, underwater acoustics, and marine instruments. Dr. Ramdas received the National Meritorious Invention Award under the category of National Societal Innovation Award 2018 from NRDC, the Department of Scientific and Industrial Research, Government of India, and the National Geoscience Award for the year 2010 under the Exploration of Oil and Natural Gas from the Ministry of Mines, Government of India. He is a member of several national and international professional societies like the Naval Research Board, review committees of NSTL and CVRDE of DRDO, the National Gas Hybrid Program, the Research Council of Tamil Nadu, Dr. J. Jayalalitha Fisheries University, India-Norway Task Force for the Blue Economy, and Indian delegation to the International Seabed Authority. Some of his outstanding contributions are the establishment of acoustic and electronics test facilities, the development of acoustic tide gauge, and also the establishment of an 8-node ATG network, development of algorithms and test rigs for tsunami early warning system. He was a chief scientist for more than 20 scientific expeditions and led various search operations for civilian and defense sectors using in-house remotely operated vehicles, and led the team to Antarctica as part of the 34th Indian scientific expedition and qualified the indigenously developed polar remotely operated vehicle in the eastern Antarctica. Dr. Ramdas has got about 11 patents for his outstanding contribution for science and technology. So with this brief introduction, I welcome our invited speaker, Dr. J. Ramdas, for delivering the invited talk. And the topic is on technology for exploration of ocean resources. Thank you very much.
Thank you very much, Professor Bhaskaran. And I understand that I have 21 minutes left, right?
Yes, sir. You can actually have, yeah.
Yeah, okay. I'll try to complete it within this stipulated time. Okay. Good morning, Professor Bhaskaran and Dr. Josia, Dr. Srivastava, participants of this conference, and particularly in this session. And I thank the organizers for giving me this opportunity to share my experience in exploration of ocean resources. I'll share my screen. Hope it's visible.
Yes, sir. Yes, sir. It is visible, sir.
Yeah. So I titled my talk with the development of technology for the exploration and harvesting of the deep ocean minerals. Some of you must be already wondering why I use the word harvesting, because we don't like the word exploitation. It has some wrong connotation. So we use the word harvesting. Exactly, we are not going to reproduce actually what we are taking out, but that is actually the idea that we have to not only take out, but we have to really again regenerate these resources. That's the idea behind this. This is the outline of my talk. I'll be going into brief history. Later, I'll be introducing you to the deep ocean minerals, and then how do we survey and sample these things, and what is the technology development that is required world scenario. And then we go into Indian efforts like a case study. And then we will discuss briefly about future work. Then I summarize my talk. So we always hear that 75% of the or 70% of the Earth is covered by oceans. It is not mere cliche. Actually, it means that only 25% or 30% of the land is available to us. In that, habitable land is only 71% of that, really 30%. If you see that way, only 1% of the land is available for the mining, terrestrial mining. And we have been using and abusing this land for many thousands of years. So we are at the end of the tether now. So, but imagine if 1% of the land can give you so much, the covered one, that 30%, how much can it give? So, such are the riches that are available to us in the ocean, still untapped. So, if you see the distribution of the minerals in the world, you can see the unfairness. The poorest continent in the world has the richest abundance of these minerals, but that is a irony. But these are not going to last forever. Some of the minerals will be lasting for maybe a few decades more, but some of them are going to get exhausted very soon, maybe in the period of some decades. But what are the elevating factors? How can we overcome this problem? We can do more exploration in the sense that we can find out where more areas of this abundance of these minerals can be found out, or we can have better technology to reduce the consumption as well as increase the efficiency of production, and we can reclassify also. We can there are some reserves and there are some resources, so we can actually, with a better technology, we can we can upgrade these resources to reserve status. Okay, but if all these things, ocean mining looks very imminent. The question is if whether we have to. No, the question is when and how to do it. Okay, this is actually for those people who know about science fiction. Jules Verne long back predicted in 1870 itself that ocean depths there are mines of zinc, iron, silver, gold that would be quite easy to exploit. He was right, but he was not right about easy to exploit. So there is no one way of classifying the ocean minerals, but this is my way of looking at these ocean resources. They can be living, they can be non-living, and in the non-living again, they can be renewable and non-renewable. And today we are going to talk about minerals that are actually available, basically seabed minerals. I'm not going to talk about the dissolved minerals. So seabed minerals can be oil and natural gas, even gas hydrates, diamonds, polymetallic nodules, cobalt crust. And dissolved minerals can be salts, uranium, and other metals, which we are not going to talk about. And where are these available? They are available in the ocean, obviously, but ocean can be, it can be actually broadly divided into EEZ of the nations and the common heritage of the mankind. So EEZ up to 200 nautical miles from the coast. It can be even extended EEZ also is now talked about. But the other area is actually called high seas. And there the land that is actually the seabed actually is called the area, and it is actually the common heritage of the mankind. But United Nations International Code Authority can allot these areas to the nations. So these are the seabed minerals of our interest. One is the gas hydrates, which occur at anywhere between 1,000 meters to 3,000 meters depth, and 50 meters to 500 meters below the seafloor. And they are rich in, I'll come to that point later. Then hydrothermal polymetallic nodules, which occur in the abyssal plains at around more than 5,000 meters water depth. They are rich in cobalt, nickel, and manganese. And cobalt crust, which occur on the sea mounts, that sides of the sea mounts at around 2,500 meters water depth. And finally, polymetallic sulfides, massive sulfides, which occur at the ridges and where the continental actually the tectonic plates meet, actually that in that crevices the hot magma tries to come out and water tries to seep in, and the steam that is generated, it brings out the minerals from the earth crust to the that seabed. So gas hydrates, actually, as I told you, they occur in the sediments of the ocean or in the permafrost regions. Each cubic meter of gas hydrate is actually a crystal containing water and methane gas, and it can release 163 cubic meters of gas. So India has a large potential of these things. Whether they are the potential future energy, that is a question to be addressed. Second one is the polymetallic nodules. As I told, they are actually rich in cobalt, nickel, manganese, and even iron. And they occur at around 5,000 meters water depth, especially in Pacific and Indian Oceans. And they look like potatoes, around 10 centimeters in size in average. And they grow, it takes millions of years to grow. They are actually two-dimensional minerals lying on the seabed. Okay, so India is considered a pioneer investor by the International Civil Authority, United Nations, and in 1987 we have been given this status, and in 2002 we have signed an agreement with them where we got around 150,000 square kilometers of land in the Indian Ocean, that 13 degrees to 10 degrees south after crossing the equator. And these are rich in manganese, cobalt, nickel, and copper. Around 380 million tons of million metric tons of these nodules are available for picking. Similarly, this is the hydrothermal sulfides. They are available at around 26 degrees south in the southern Indian Ocean. They are rich in again the sulfides of this iron, copper, and zinc, and also to some extent in barium and calcium. And you can see this is a triple grid junction at around 26 degrees south. We have been given around 10,000 square kilometers by International Civil Authority. And cobalt crusts, of course, they are actually on the sides of the mounts. They are not exactly 2D minerals. We have to scrap them out and we have to cut it out actually. So, but why we can't, how difficult it is to really harness or use these resources, because it's more difficult than the terrestrial ones. For this audience, I need not tell how difficult it is to conquer the universe space. These are the difficulties in more dynamic medium, hydrostatic pressure, around 500 bar, it is at 5,000 meters. And finally, there is no electromagnetic communication. So you don't know where you are going. You don't have any communication with the mothership without the cable. If you have the cable, then drag is very high. So with all these difficulties, there is no other way. We have to venture into the ocean for our future needs. So these are the components of the exploration. First, you have to survey whether they are there or not. And then we have to sample and see what is the abundance and what is the grade of the minerals. Environmental, whether it is safe to or how badly environment will be affected by removing these minerals. Then exploratory mining, then commercial mining, and then we have to close down and we have to clean after ourselves. And in the survey techniques, there are different kinds of surveys: seismic, acoustic, geophysical, and imaging. In the seismic survey, this is mainly used for the oil and natural gas. There are two things. One is reflection by and another refraction. There is a source, seismic source. It can be air gun or some explosive source or something like that. And the receivers are towed behind, and the layers of the seabed are studied for the minerals. Next one is acoustics. You can see this is typical echo sounder. You send acoustic beam and you study the reflection. It can be a single beam, like a searchlight actually, but it takes a large time to cover this area. But if you have multiple beams, it is called multi-beam. And next one is side scan. This is used as a camera actually, like an acoustic camera. The sea bottom is actually imaged, and there are some special kind of sonars which study the sea bottom also. But how do you take them to the bottom? You need some kind of vehicles to carry these search tools to the bottom. So there are different kinds of vehicles. Again, we can classify them into manned and unmanned. We are not going to talk about military submarines, but mostly India is concentrating on the unmanned submersibles, and we are soon going into the manned submersible. The first of its kind is actually, the first of this kind is actually a tow body which can be towed behind a ship, either with a umbilical cable carrying the power and the signals, or just a rope with the recording devices on the tow body. We can put as many sensors as you want, like sonars, collectors, everything. Next one is slightly advanced version. That is actually a remotely operated vehicle. A long cable is there, which actually allows us to supply power and drive this robo. It can do exploration as well as intervention. Next one is autonomous vehicle. This doesn't have the cable, but it can work on its own, but it has to be pre-programmed. You don't get to see what it is doing or what it is seeing. You only once it resurfaces, you can download the data and the images. So, but now we have surveyed using surveying techniques, but how do you sample these things? There are different sampling techniques called grabs, dredges, and cores. Grabs are nothing but literally they grab what is there on the seabed. You can see this is a celebrated Van Mien grab. You can lower it with the cable, and when you pull it, actually this bucket is closed, and these things are trapped, minerals are trapped in this one. But there are some things called boomerang grabs, which are very well known to our pioneers of NIO Goa, they just go down without a cable, they collect the sample, and again they surface and these are collected back. And once that is one way of collecting, otherwise it's just dredging. You take a heavy rim and put a fine sieve behind that one, drag it on the sea floor, and based on the size of the minerals, sieve can be sized actually. And if you want undisturbed samples, then we have to use corers. The corer, because of its own weight, it penetrates the bottom and collects a sample and it picks it back. There are different types of corers, tube corers and box corers. And now we have done everything, but how do you mine them? There are kinds of underwater mining machines which dwell on the sea bottom. You can have a tracked vehicle like a military tank, or it can be an Archimedes screw, it can move forward. The simple one is actually sled that is actually dragged behind a ship. This is a typical example of a crawler used by Korea. They have done up to a maximum depth of 1300 meters. And Japan and China has used the Archimedes screw, and Japan used a sled. And after having the vehicle to go on the bottom, there will be some tool to collect it actually. So you can have a passive collector. When this vehicle moves, it automatically the nodules are collected, or it can be a potato like harvesting to pick up the nodules. We can have some active tool. It can be a mechanical one, or it can be just a hydraulic lift system. Once you collect it, you have to send it back to the mothership. How do you do it actually for 6,000 meters? You can have a series of buckets within a rope, and you can just circulate this rope and you can lift the mineral using these buckets. But it's not a very efficient method. May be useful for diamonds on the lower depths, but in the deeper depths, it's a failure. Second technique is to send a shuttle, wireless shuttle, fill the nodules with these things and then bring it back. It was not a huge success, but this technique has been really the successful in the world. That is actually to have a long riser, whether it is flexible or rigid or partly flexible, partly riser. It's called Yamano type actually. You have a pump here and you can pump the nodules mixed with seawater to the surface. And this can be done in two ways. One is by pumping air, high pressure air to the bottom and using that bubbles to lift these things. Or you can have a pump at the bottom. Again, these pumps can be ordinary centrifugal pumps, or it can be positive displacement pumps. But mostly positive displacement pumps are used in this kind of purpose because mechanical centrifugal pumps have their own problems in this. But when we do this one, there are environmental issues. Obviously, you are disturbing the seabed, which has been very dormant for millions of years. And after you bring it up, actually, again, your tailings are being put back into the sea. All this, even sediments are put back into the sea. They should not be disturbing this botanic zone, actually. So you have to take enough care for that one. So if you see the technology, so only a few countries are active in this one. And India is actually in the forefront. I'm happy to inform this August audience. And US has done a massive experiment in 1974, but for some reasons, actually, they have left it after putting some 600 tons of nodules. It's actually a camouflaged experiment that is mainly for actually taking out one sank submarine, actually, that sunk submarine belonging to USSR at the time. Then Korea has done it at around 1300 meters water depth. Recently, Belgium has done it up to 4,500 meters water depth. They have not brought the nodules up, but they have just collected the nodules. And finally, Japan has demonstrated it in their own backyard at 1600 meters water depth. For hydrothermal sulfides, they are lucky to have these things in their EEZ. But if you come to India, India has a PMN program. It has exploration, survey, mining technology, and metallurgy. NIO Goa and NIOT and IMT Bhubaneswar are involved in these things. And we got 1,50,000 square kilometers here, and we have given back 75,000 square kilometers after the survey. And we started developing a concept called flexible riser configuration, where a machine can be sent with a cable like this, and it can dwell on the seabed, it can move on the seabed and collect the nodules and pump them back. There are several advantages and disadvantages. Advantages is that actually it is one failure will not cause the catastrophic failure. it is relatively easy when compared to others. So we started taking a trawler which is belonging to one German university. We started pumping sand from around 500 meters water depth, and we demonstrated end to end. But we were not satisfied with that. We signed a contract with the International Seabed Authority from in 2002. As a consequence of that one, we converted our sand mining system into nodule mining system like this. And after extensive testing, we have done it at 500 meters. There are no nodules. So we made artificial nodules and spread them on the seabed, and we pumped them to the surface. And we are the first country to do it at 500 meters end to end. Later, our work is at 5,000 meters. So we started exploring the water column as well as the seabed. Seabed is very soft there. Whatever you keep there, it sinks in no time. Actually, it's like a grease. So we made instruments to study the seabed. That is actually how hard it is or how soft it is. It's called in situ soil tester. We used it at 5,400 meters and we tested the soil there. And for exploring the water column, we made an ROV, remotely operated work vehicle, which is actually a exploratory tool. But for 7,000 meters, we made some concept like satellite launcher, and satellite actually, it goes to the seabed, actually it gets separated and it swims around, and when it is actually work is over, it gets docked back to the tether management system and it is lifted back. All these three mineral resources were surveyed using this tool. And with this input, we started developing a underwater mining trawler. We estimated what are the different resistance that are come onto the trawler. So with all these things, we started developing, and we used a concept called a vertical riser system. And these are the components. This is a seabed ship systems, that is water column systems and the seabed systems. So we sized them, we designed them, we procured them and tested them. And this is where this is the laboratory. We take it to the ship, we sit there and operate this one. And I'm happy to inform, these are some of the pictures of the machine and the seabed. Actually, I'm happy to tell this audience that recently, during the pandemic itself, we have done it at 5,270 meters. We demonstrated our mining machine. It's a world record. We are at to pump these nodules to the top. We are also involved in the environmental impact studies of this one. With all these things, these are our future plans. By 2025 or 24, we will try to demonstrate the actually a demonstrative mining system at Indian Ocean. And whatever nodules were collected, they were given to IMD Bhubaneswar, and they were able to extract the copper, cobalt, and nickel from this thing. They made sheets. So technical viability is that, once again, I reiterate that India is in the forefront. We are actually not lagging behind anybody in this one. So commercial viability is yet to be established. The initial studies say that it's viable. Let us see how it happens. And all these things, we know that there are limitations in the autonomous systems and the remote systems. So we started making one manned submersible which can go down to these depths. These systems were earlier used by US and other countries in hydrothermal vent exploration, especially by Japan. And these are some of the components of the manned submersible. This cartoon explains what are the systems that are involved, and NIOT is involved in developing this system. Okay, so far only 5 countries in the world has this kind of system. China has added Geolong to that one. Now with this background, NIOT and MOES is involved in making a system with their broad specifications. It doesn't have any cable. It can take 3 human beings, normal human beings. No additional training is required. So these are the specifications. The critical technologies, the man-ratedness is actually a very critical requirement for this one. So redundancies to be built in, and this is actually, we are in the process, almost half the process is completed. And with this, India is the only country to have all kinds of entire portfolio of these vehicles for the exploration of mineral resources of the ocean. And these are areas where India has worked from, starting from Indian coast to the Antarctic coast. We have covered everything. And this is a summary. Ocean is a treasure trove of, I'm sorry for the spelling mistake here, strategic minerals. And whereas land minerals are getting depleted, ocean mining is imminent, technology is maturing, and India is in the forefront. MOE's Minister of Health Sciences is actually spearheading this effort. This technology should be technically, economically, and environmentally viable. So industry has to be involved. Expertise, equipment, environment, ecology, and economy are the buzzwords. And this I have taken from the first experiment done in the deep sea mining by US. The impossible is indeed possible when talented engineers with the courage to take prudent risks are provided as an incentive to stretch the state of the art. Okay, before I conclude, I would like to inform you all that the Ministry of Health Sciences is spearheading one deep ocean mission. Honorable Prime Minister of India has announced this mission and it has been sanctioned. It has got 6 components, as you can see from here. In these, 2 of the components, that is deep sea mining, underwater vehicles, underwater robotics, and exploration. This is deep ocean survey and exploration. These 2 diagonally opposite these things are actually the verticals are mainly meant for deep ocean resource exploration. So all of you are actually invited to participate in this mission of national importance. I once again thank the organizers for this opportunity. Thank you.
So thank you, Dr. Ramdas. It was a very informative and exhaustive and enlightening talk. And the talk is very important in context to this deep ocean mission, which is proposed by the government of India on technology development. The talk really covered the broad gamut of ideas, starting from the mineral supply and demand, ocean resources, specifically on the seabed minerals like gas hydrates and polymetallic nodules. The talk was very informative on the challenges of the underwater technologies and the importance of seismic surveys. A broad overview of the underwater vehicles, the remotely operated vehicles, etc. were given, and it was very nice to listen to this talk. Finally, you have touched upon the environmental issues, which are also equally important. It was an excellent talk, and we're very happy to listen to this talk. So Josiah, can you just please make out if any questions are there on the YouTube link from the audience?
Rohit, could you see any questions? No, sir, we don't.
No, sir, we can't see any question.
So there are no questions. Okay.
I take it as a compliment. I think that everybody has understood whatever.
Yes, the talk was really nice, sir. It was an excellent talk. Yeah.
Sir, there is. Can you all the participants are requested to switch on their camera so we can have a quick group photo.
Yeah, we can have a photograph. Yeah, we can.
I think participants are not switching on the camera.
Yeah, I could see Ramesha. Ramesha has switched on. Keshav Kumar is switched on. Yeah. So.
Sir, am I visible?
Yes, you are visible.
Yes, please. So I think we can proceed.
Yeah, thank you. Thank you very much.
Thank you.
So I think now we can proceed to our next sessions of oral presentation. We have 11 presentations, and the first presentation is by Dr. T.V. Ramesha. The title of the presentation is an experimental study on the maneuvering of a container ship in regular waves.
Okay, thank you, sir. I will share my screen.
Yeah. Yes, Ramesh, you're able to load the presentation?
Yeah, yes, sir. I am trying, sir.
Okay. No, I think the presentation is not yet loaded. It is not yet loaded. We cannot. So probably, I think, Rohit, can you help if suppose you have a backup of this presentation, no? This PPT slides.
I think it is coming up, sir.
Yes, yes, it is coming up now. Yeah. Yes, it is. It is okay
Yes.
now. Yeah. Yes, Ramesha, you can start. Actually, you can make it in the full screen mode and you can start. Yes, please start. Ramesha, you're muted. You're muted.
Okay, sir.
Okay. Please
Yeah.
start.
Yeah. Okay. Okay, sir. A very good morning, all of you. I am Dr. Remisha. I'm working as an assistant professor in the Department of Civil Engineering, Cochin University of Science and Technology. And I have carried out this research work under the supervision of Dr. P. Krishnankuti. He's a professor in the Department of Ocean Engineering, IIT Madras. And the topic of the today presentation is experimental study on the maneuvering of a container ship in regular waves. Okay. Okay. Basically, maneuvering is the ability of a ship to keep or change its course under control action. And this maneuvering prediction will give valuable information about ship's turning ability, directional stability in the early design stages itself. And the maneuvering prediction can be done by different methods, by conducting full-scale model tests, free-running model tests, and captive model test. This full-scale model test and free-running model test give the maneuvering trajectory or maneuvering parameters directly. But in the case of captive model test, we have to choose a mathematical model, and the hydrodynamic derivatives in the model can be estimated using by conducting different captive model tests like straight line test and planar motion mechanism test. And these derivatives can be fitted into the maneuvering equation of model to get the trajectory and the consequent maneuvering parameters. Okay, then today we are discussing on maneuvering in waves. Why the maneuvering in waves is so important? Because traditionally maneuvering characteristics are studied in calm water condition, but ship always sails through waves, and it will behave differently in waves compared to calm water. And also the effect of wave forces reduces the course keeping and course changing ability of the ship, and which will increase the resistance to ship forward motion, and which will alter both rudder and propeller efficiency. So the effect of waves need to be included in the maneuvering mathematical model. That's the importance of this study. There are so much of literatures have done previously by different researchers. The main important one are Seo and Kim in 2011 has carried out a numerical study in maneuvering in waves. Similarly, Skejik and Foltison in 2013 based on the approach based on two time scale models. In the approach of a two-time scale model, the sea-keeping and both maneuvering part are computed and which is simulated to get the trajectory in waves. Also in 2007, Xu et al. And Takeshi which, conducted PMM test in waves to determine the effect of drift forces in the controllability of ship. And in 2006, Yeshukova performed free-running model test in both regular and irregular waves. And also in 2005, Fang et al. Developed a 6 degrees of freedom mathematical model in calm water and in wave condition. And also Bailey et al. In 1998 and Lee in 1997 has conducted maneuvering study based on unified theory. That is another approach for calculating the maneuvering prediction, for estimating the prediction of maneuvering in waves. And also Fosen and Sketch have also developed the unified state space model to predict the ship maneuvering in waves. Okay. Then here, the main objective of the present study is to investigate the regular effect of waves in the performance of a container ship experimentally by conducting free running model test. So in free running model test, ship maneuvering characteristics are computed in the early design stage, which is a more direct experimental technique. And in this, a self-propelled model is used, which is fitted with appendages, and standard maneuvering tests like turning circle tests are executed here. And these tests are conducted in both in calm water, still water condition, and also in regular wave with a different wave height and wavelength. And these studies are conducted at the Seakeeping and Maneuvering Basin Facility of Naval Science and Technology Laboratory, Visakhapatnam. And the basin dimensions are 135-meter long and 37-meter wide, 5-meter deep, which is fitted with 256-inch flap type paddle on longitudinal and transverse direction of the basin. This is the KCS container ship has chosen for the study, which is already studied by different authors and presented in different CMAN conferences. And the particulars of the model has given. The length in full scale is 230 meter and the model scale is 3.04. Other dimension like breadth, draft and displacement, everything has given in the table. And also the propeller and propeller model, full scale and model scale details are given. Number of blades are 5 and pitch by diameter ratio, rotation, hub ratio, everything is given. And this is the setup, experimental setup we have used to conduct the turning circle test in waves in the naval in the Seakeeping and Maneuvering Basin of NSTL Visakhapatnam, and which uses a wire control model in which carriage follow the model during free sail test, and model tests are conducted in deep water condition. This is the experimental setup. We can see the cameras, tracking cameras, and also there is passive markers we have attached with the model, and propeller and rudder motors and dynamometer are fitted to measure the force component. And the tracking system, which is consists of 4 Qualisys cameras, which is mounted on the carriage. And this is the experiment setup turning circle test we have conducted in calm water and also in regular wave conditions. In which the wire control model we have used so that the carriage will follow the model itself. This is in the case of calm water, and in the case of waves as shown here. This is the result of the present experimental setup, this turning circle test in calm water and also in wave condition. Turning circle parameters are also given. You can see the red dotted lines. This is the turning circle in waves and it is in the calm water. And turning circle tests are conducted in regular waves with different wave heights also. You can see a drift in the direction of wave. We have used HC wave condition so that the trajectory in waves has drifted towards the wave direction. and the experimental tests are conducted in different wave height also. The different wave height we have chosen, and the advanced and tactical diameter turning circle parameters like advanced and tactical diameter from the present steady. This is actually compared in calm water condition for the present steady, and also cement 2008 results are compared. Okay, so maneuvering in waves with different wave height, 3 different wave height we have chosen, and we can see the drift of the ship has increased as the wave height increases. Okay, similarly, the turning circle parameters like steady turning radius, transfer, advance, and tactical diameters are compared in calm water and also in wave condition, and the percentage of deviation from wave and still water conditions are also we have figured out. And turning circle parameters in calm water and the wave height, also wave height with different wave heights of 0.013 and 0.019, 0.026 are tabulated here. And turning circle trajectory in waves is found to be drifted towards the wave direction, and the vessel drift is increases as the height of the wave increases. This is in the case of wavelength, different lambda by L values. This is lambda is the wavelength and L is the ship model length. For different lambda by L values, we have compared with the calm water and the wave condition 0.5, 1, 1.5, 2, and 2.5. Here you can see as the wavelength increases, the drift of the ship has reduced. This phenomena is already this as the wavelength increases, the drift of the ship has found to be decreased. This is already has shown in previous literatures also. As the wavelength increases, the drift of the ship is shown to be reduced. Okay, I'm concluding the effect of wave on maneuvering characteristics. Free running model tests are conducted in still water in headwind condition, and turning trajectory in waves are found to be drifted towards the wave direction, and the drift of the vessel increases as the wave height increases. And similar trends are reported in literature, which is Fang et al. In 2005 and Sang et al. In 2017. They have conducted in S-175 container ship, not in KCS. And wavelength also has a considerable effect on maneuvering. Longer wave has less effect on turning characteristics of the ship. Similar trends was reported by Fang et al. In 2005. And result of simulation project, the influence of wave on the maneuvering characteristics of the vessel. These are the references. So in the maneuvering characteristics, so the IMO present regulations need to be considered the effect of waves on maneuvering of ships. Okay, these are the references. These are thank you very much for your kind attention.
So thank you, Dr. Ramesha. It is very, very interesting presentation.
Okay, thank you, sir.
Are there any questions from the audience? Josia?
No, sir. There are no questions.
So
I think.
Yeah, so Ramesha, I have some couple of questions.
Okay, sir.
So my first question is, in your presentation, you have mentioned about the water particle kinematics that is affected around the ship.
Yeah, yes, sir.
And how does it actually attribute to the hydrodynamic forces? The water particle kinematics.
Okay. Actually, in wave condition, actually we have the same work we have carried out numerically also.
Okay.
Numerically also we have carried out by conducting simulating PMM test in waves, so that we will get the hydrodynamic forces correctly.
So fine. So you have calculated from the PMM test actually.
Yeah, PMM test. In numerically we didn't simulated the free running model test. We have carried out captive model test, PMM test in waves using CFD software. Fine. In that we have find out the hydrodynamic forces.
Okay,
I got
the point. It is okay. Now my second question is like, you have used actually different model wave heights like 0.13 meters, 0.019, 0.026. These are the wave heights that you have used in your laboratory test.
Yes.
And you have used different wavelengths like 1.5 meters, 3 meters, 4.5, 6, and 7 meters. 7.5, 7.5 meters. So this was used in your study. So suppose you want to do a geometric scaling of it. What would be the appropriate wave heights and wavelength in the real sea state?
Real sea state. Actually, we have taken a model scale of 75.5. 1:75.5 we have taken. So it is corresponding to 1 meter, 1.5 and 2 meter wave height.
Okay, fine. So fine. So it is basically maximum going up to 2 meters wave height.
Yeah,
okay.
2 meter wave height.
So in your presentation, actually, you have mentioned about the role of wave direction and wavelength, which has a considerable effect on the vessel maneuvering characteristics.
Yeah. We have considered only one wave direction, sir. Only head wave condition only we have.
So can you quantify? So can you quantify what is the relative contribution from both, or which is important? Wave direction is important, or the wavelength is important?
Wave direction is actually important, which is drifted
good.
towards
So you're
the
finding
wave
the wave direction is important one.
Wave direction is important.
Fine. So thank you very much, Dr. Manisha. It was a very interesting presentation. Yeah.
Okay, thank you. Thank you very much, sir.
So I think now we'll go to our next presentation, that is by Sri Lakshmi. Sri Lakshmi, yes. And the topic is variability and directional analysis of extreme swell wave energy flux in the Indian Ocean. So Sri Lakshmi, you can just start your presentation. Yes, the slides are loaded. Yeah, you can make it full screen. Yeah. Okay.
I'm audible, sir?
Yes, you're audible.
Thank you, sir. I'm just checking whether it is working.
Yes, the slides are moving.
Yes, sir. Thank you, sir. Good morning to everyone. Myself, Sri Lakshmi. I'm a research scholar from the Indian Institute of Technology, Kharagpur. I'm working under Professor Prasad Kumar Bhaskaran. Today, I'm going to talk about the variability and distributional analysis of extreme swell wave energy flux in the Indian Ocean. So I will be finishing my talk within 10 minutes, and the presentation includes a brief description regarding the swell waves, data methodology, results of discussion, and conclusion. So basically, swell waves are wind-generated waves. The wind-generated waves are the major waves that we observe over the sea surface, and they are of two kinds, wind sea and the swell waves. The difference between the wind sea and the swell waves are the difference in the frequency and the steepness of their wave structure. So swell waves are considered as long waves having a wave period more than 12 seconds or 14 seconds. And they can travel leaving the generation area up to thousands of kilometers and having a travel speed more than that of the wind speed. And the significance of these swell waves, more than 75% of the global wave energy is composed of swell energy, and 90% of the wave energy in the tropical region is contributed by the swell waves. The major source of the swell waves are considered as extratropical regions, including in the Southern Ocean and the Arctic Ocean. If we consider the southern hemisphere, the Indian sector of Southern Ocean is observed with the maximum wind speed and also having the wave energy. However, later the wave energy is distributed to the other regions also. The extratropical swell waves that is generated in the southern sector can reach the Indian coast within a travel time of 5 days. And these swell waves can actually modify the local wave climate in the near coast regions. And also, in many times, these swell waves are causing a flash flooding and a high wave activity, reasoning for a eroding nature in along the coast. So during their propagation from the generation area to other parts, the travel processes, including the attenuation of wave energy and the change in direction. So these two processes will be achieved by the dissipative and non-dissipative mechanism, such as the interaction with the other waves, the high wind loads with currents, and the interaction with the land masses, ice covers, that will cause the change in direction, which we call as wave transformation, such as wave refraction and diffraction. These processes will change the propagation characteristics, the direction and the energy. So the change in propagation characteristics makes the forecasting of this wave climate over a location very challenging. So our aim in this talk is to understand swell wave energy potential and its directional distribution in the Indian Ocean. So swell wave energy flux denotes the available amount of energy at a location, whereas the directional wave energy flux indicate the directional characteristic of a local wave field. So coming to the data, here we have used the ERA5 fifth generation ECMWF data for 42 years of period. We have downloaded, archived the significant wave height, mean wave period, mean wave direction, and wave directional spread of the total swell waves. And we have used the wave energy flux directional wave energy formula as follows. And we we have mentioned that the variability in our interest is the extreme swell wave energy. We have used the generalized extreme value analysis to estimate the extreme climate of the swell waves. This is the combination of three families of extreme data data families, like Weibull, Frechet, and Gumbel. So we will get three parameters from this model, and out of that, the location parameter is the center of the density function. So we have used as to represent the extreme climate as the location parameter from this analysis. So we have carried out all the analysis for seasonal scale, like June, July, August, September, October, November, December, January, February, and March, April, May. So coming to the results. So this is the extreme swell wave energy flux in the Indian Ocean. So using 42 years of seasonal maximum values. During June, July, August, the maximum wave energy is observed along the extratropical regions, and the minimum wave energy loading is found during December, January, February. As far as the North Indian Ocean is considered, the southwest monsoon is a very influencing parameter in the North Indian Ocean during June, July, August, and they are very dominant over that area in generating and distributing the swell waves. The Central Arabian Sea as well as the Northern Bay of Bengal is found with a high load of swell wave energy flux. So I have some issues with the presentation.
Would you like me to share your screen?
Please.
I have your.
Yeah. Yes, actually, I have some notations in my figure.
Okay. Okay. So not the screen problem; it's your speaker problem. Hello.
Yes.
It's a slide problem or your this voice problem.
No, I have some markings in the slide, but it is not coming. It is going directly.
Okay, if you want, I can share. I have received your slides today morning.
If you could please share.
Yeah. So you unshare, I will share.
I will stop sharing.
Yeah, yeah. please.
I'm sorry for the inconvenience. You can start from the 4th slide.
Is it?
Yes.
Next.
Next. Oh, okay, it is not coming. I'm sorry for that. Okay, the last slide is fine. I will explain it.
Okay.
The previous one.
Previous, this one.
Thank you. Okay, so coming to the non-monsoon, pre-monsoon and the pre-monsoon and the post-monsoon seasons, the direction is are almost identical, and this is the period where the extratropical South Indian Ocean swells are very influencing over the North Indian Ocean. And as we can see that the other swell wave loads are there, like in the Arabian Sea and the northern Bay of Bengal, and also compared to the Arabian Sea, Bay of Bengal region is having the maximum influence of the extratropical swell waves. The magnitude of Indian Ocean swell waves are associated with the extratropical South Indian Ocean swells for the pre-monsoon and the post-monsoon seasons. So we can go to the next slide. Now we are checking the trend of swell wave energy. So basically, the extratropical regions are observed with an increasing trend of high extreme swell wave energy. And coming to the northern Indian Ocean, during June, July, August, and September, October, November, this is the time of southwest monsoon. This is also having an increasing trend in the northern Indian Ocean. And coming to the Australia and Madagascar coming to the southwest coast of Australia and the Madagascar coast, these are the areas where the swell waves are getting modulated in their direction also and energy. So these are the area where the trend of wave energy is found to be increasing. Next. This is a representation of the variability of swell wave energy flux, and this is calculated as the ratio between standard deviation and mean wave energy flux. As we can see, the Arabian Sea side of the Indian Ocean is observed with a high variability in the swell wave energy flux as an annual scale. But very interestingly, during June, July, August, where we have seen a high wave load in the North Indian Ocean, especially in the Arabian Sea, is very stable regarding the swell wave energy. However, in the other seasons, like non-monsoon seasons, September to March, the variability of swell waves are found to be varying. This can be due to the presence of Shamal waves and the Makran waves, as well as the northeast monsoon waves. Next. Okay, different from the energy flux, the directional distribution of swell wave energy will gives you the idea about the directional characteristics of the swell waves in the area. So we can see during December, January, February, the energy flux was very minimum regarding the energy flux was very minimum. However, during this same period, the directional wave energy is not that minimum. So that means the spreading of wave is somewhat larger than the propagation wave, propagational wave direction. There are some notations. Okay. So these two areas are having a high load of directional distribution of swell wave energy, and we assume that this is the generation of swell waves. From the northern Bay of Bengal also, there is a generation of swell waves that can propagate towards the southern side. And in the September, October, November also, there's under influence of southwest monsoon, there is a generation of swell waves. And in December, January, February, in the Gulf of Oman, there is a load of wave energy, which is due to the onset of Shamal waves. And during December, January, February, we have analyzed the directional spread of the swell waves also. So we found that the waves that coming from the western side of extratropical regions reaches the north of Madagascar, and at the influence of Seychelles Islands, some wave transformation is carried out like diffraction, and the swell waves from the extratropical region, and this is a time where northeast monsoon is dominant. So the northeast monsoon swells are interacting, and the region of the Somalia coast is having a very low energy that we have observed in the energy flux. So coming to the directionality of the swell waves that is propagating from the extratropical to the northern.
You have 1 more minute. Can you please speed up?
Yes. So the swell waves are under the influence of the islands that is existing in the existing in the tropical regions. Next slide will be conclusions. So the conclusion are the historic maxima of Indian Ocean are observed in the Southern Ocean. So the extratropical region, the energy is found to be increasing. The directionality of the swell wave energy is highly influenced by the islands in the tropical region. And also the southwest monsoon, northeast monsoon are also, and Shamal waves and Makran waves influence the swell climate over the North Indian Ocean. This will be this kind of works need to explicitly studied with the other parameters such as current, the existing wind system, the other wave system to a better predictive wave climate. Thank you, sir. This is from my side.
Okay. So thank you, Sri Lakshmi. It's a very interesting presentation. So are there any questions from the audience?
No, sir. There are no questions.
Okay, so Sri Lakshmi,
Yes,
I have some couple of questions.
yes, sir.
So in your study, do you find any variations which is observed, especially in the spatial distribution of extreme swell wave energy flux on a decadal scale?
Decadal scale.
You're taking about 42 years of data. Yeah.
Sir, actually that during the temporal trend analysis, the energy flux is actually increasing, especially in the extratropical regions, which we haven't seen the figures in this presentation, but the trend is actually increasing, especially in the extratropical region. And also the southwest monsoon also, the energy is increasing.
Okay. You're finding the energy increase during the southwest monsoon time also on the northern part of the Indian Ocean.
Yes,
okay.
Yes.
Okay, so that is interesting. Okay, and the second question what I have is, since you're looking into a basin scale propagation characteristics of the swells, so we can call it as a great circle swell propagation.
Yes, sir. Actually, the swell propagates through the great circles only.
Great circle arcs. So how does the local winds, or you can say local wind waves affect the propagation characteristics?
Actually, sir, swell waves modify the local wind seas that is present due to the local wind characteristics. They will modify the roughness of that wind-sea spectra. Basically, sometimes it will be constructive, sometimes it will be destructive according to the direction of that location.
Okay, fine. So you're attributing it to the directional characteristics, basically, right?
Yes, sir.
Of the propagation. So my last question to you is: you have used the generalized extreme value analysis in your study, right?
Yes,
You have
sir.
used actually the Weibull, Fetchett, and the Gumbel distributions, a combination of this. So what are the strength and weakness that you find in this GEV analysis in the context of the analysis that you have done? Because I know that GEV is a very popularly used method, but there are some limitations in using this method.
Sir, I guess.
Okay, fine. So thank you. So thank you very much, Sri Lakshmi, for the interesting
Sir, I
presentation.
have a few questions.
Yes, ma'am.
So, Sri Lakshmi, it was a wonderful presentation. You have utilized a long data set, long period data set. So, I have a question like, can you please tell the potential wave energy zones in the North Indian Ocean? If you wanted to have a wave energy plant, so which are the locations you would suggest?
Ma'am, it is basically based on the stability of the waves. Both the Indian coast are having a very high variability regarding the wave energy, especially in the southwest monsoon. But however, even though the we can go for the seasonal or monthly stability analysis. However, the wave energy is low. The western part and the means the northeastern and north southern part will be more stable than the southern parts, because the influence of swell and wave energy it is related to the seasonal variation also, ma'am. So we have to look the location and the seasonality also. So the northeast and northwest will be more suitable.
Okay, Sri Lakshmi. Actually, I have one quick question also. So now, if you see, we have a lot of cyclones in our North Indian Ocean. So what will be that impact in your like swells?
Yes, ma'am. Actually, we have excluded the cyclone influence from for this study. However, the swell wave that generates during the cyclone will be very high, and that can also influence and modify the local wave climate, and can influence the sediment transportation dynamics along the coast, and that should be look after. Onwards. Thank you, ma'am.
So thank you, Sri Lakshmi. So now we'll go to, I think, the next presentation. There are no more questions. Yeah, we'll go to our next presentation. It's by B. Keshava Kumar. The title of the talk is on air quality monitoring from deep ocean mode buoy systems in the Indian Ocean. So, yeah.
Am I audible, sir?
Yes, you are audible.
Very good morning to you, sir. And also, I would like to thank the organizers for providing me the opportunity to present in this esteemed conference. So, my topic of presentation today is air quality monitoring from deep ocean mood buoy system in the Northern Indian Ocean. And the authors are myself and Mr. G. Venkateshan, Mr. Arulmuthiya, and Dr. R. Venkateshan. And we are from the Ocean Observation Systems Group of National Institute of Ocean Technology. So, these are my crisp contents. Like I'm going to discuss on these topics today: air quality measurements and present scenario of air quality measurement, and the relation between this air quality measurement and its impact, and the perspective of sustainable development goal, and need for air quality measurement, and some points about the mood buoy systems which are located in remote deep sea location, and our steps towards augmentation of air quality monitoring system with the buoy system. So, as a first step, I would like to emphasize the impact of air quality. That is, we humans breathe on an average of 28,000 times a day, which is like 10,000 liters of air in a day. And this explains the significance of measuring the air quality, and even the present pandemic situation will give us more insight, like how our people are suffering due to the scarcity of oxygen and other stuffs. So, and again, due to various industrialization like automobiles and other industries, and a lot of I need not explain all these aspects, because everybody of us know the impact of air pollution and how it is being generated. And the main air pollutants which are considered by the global body, the statutory bodies, are PM 2.5, that is particulate matter 2.5, 10, and 1. That is particulate matter, they have designated a size that this, if the size is about 2.5 micrometer, then it is designated as 2.5. That is the meaning of 2.5, 10, and 1. And the carbon monoxide, SOx, NOx, methane, oxygen, ozone, and other pollutants. So air quality index is derived from the basic lower and upper cutoff values of each parameters, and they are giving a value, and it varies from location to location and country to country, and their stringent rules, based on the stringent rules. So next one, in India, we have the Central Pollution Control Board, which is a statutory organization which imposes rules and restrictions on air pollution. And it is like an authority who questions the industries when they are not following the norms and other stuffs. So we have a national air quality monitoring program by the CPCB, and in total, we have around 793 stations operated over 344 cities and towns in 29 states and 6 UTs by this program, that is NAMP. And they concentrate mainly on, of course, some stations have some more parameters, but the main parameters are sulfur dioxide, oxygen, oxides of nitrogen, that is NOx, and then respirable suspended particles, that is basically our particulate matters and other fine granule air pollutants. And also, as well as they are measuring the meteorological parameters like wind speed, direction, relative humidity, and temperature, along with these measurements. And our ministry, the Ministry of Earth Sciences, have a program named SUFFER, which is basically implemented by the IITM, IMD, and other stakeholders, wherein they are like involved in forecasting the pollutants, like forecasting the air quality index present based on the previous values. So they measure a lot of pollutants, like again, all the particulate matters, ozone, carbon, NOx, SOx, methane, and toluenes, benzene, mercury, etc., along with some meteorological parameters and UV radiation. And presently, the stations are operated in Delhi, Pune, Mumbai, and Ahmedabad. So based on the previous value, they use HPCs to compute the values from this, and also they model for the forecasting of the air quality index and these values. So this is one of the successful program which is now in live. So again, coming to even, I would like to connect the focal theme of Osicon, which is sustainable development. So the sustainable development goal of which is 17 numbers are there, and then the 14th one is the life below water. And if you read that document, the 14th target says, the first point itself, it says, I'm just reading to emphasize the importance: prevent and significantly reduce marine pollutions of all kinds. Even some pollutants, even we may not have the idea that it is polluted. Like before, like 20 years, plastics would not be have been considered that it is having this much potential to pollute everything, like starting from the land to the deepest point in the earth, in the ocean. So like that, even whichever they kept the scenario as a broad spectrum, like even anything can come in. So we have taken this initiative. Why can't, like, only air pollution is mainly measured in land by in situ parameters? Of course, we have remote sensing techniques for ocean, but the high resolution data of air pollutants are coming only from the mainland around the globe. So we were thinking, and again, I would like to emphasize some other points by the international statutory organizations like MARPOL, that is the International Maritime Organization's body, which also has put restrictions in 1997 itself, like ship's exhaust gas should be filtered for SOx, NOx, and then they have standard values beyond which they cannot exceed the limit. And these are like checked in every foreign ports for compliance. And the Global Atmospheric Watch Program designates a lot of standards in measurement techniques as well as the values and everything. But the threshold value varies from country to country. And then the US EPA, the United States Environmental Protection Agency, also has done a lot of extensive work in setting up the targets or setting up the value or goal value of these air pollutants. And then comes the ocean observation systems. I would like to link the global shipping route, which is shown in the left side panel, which is an approximate a snapshot of global shipping routes. So, and again, one more logic is that now, as presently, there are a lot of studies going on ship's biofouling, ship's hulls biofouling and air pollution also, because when there are more barnacles or more underwater biofouling in the ship, which creates more drag, and to maintain the speed, the owners are pushed to inject more fuels into the engine and to maintain the speed. So which causes more combustion and absolutely more pollution in the environment. So these are the global shipping routes. So in the right side of the panel, I have indicated the capability of global in situ moved or drifting observation platforms, wherein we have a lot of platforms in the ocean up there measuring all the parameters, the atmospheric parameters and subsurface parameters. For other applications, not mainly for this air pollution monitoring. They are meant for climatic studies, they are meant for cyclone warning, tsunami warning, and a lot of other oceanographic processes. So this was the motivation behind us. Like what if, and again, this shows our Indian Moved Buoy Network program, wherein we have Ramabuoy systems, which is combinedly maintained by NIOT and United States Pacific Marine Environmental Laboratory. And we ourselves, NIOT, maintains 12 Omni buoy systems. That is, Omni is ocean mode buoy network in the Northern Indian Ocean, and 4 coastal buoys close to the shoreline. And then we have some tsunami buoys and a calibration validation buoy, which is deployed jointly along with the Space Application Center for validating their satellite sensors. And also we do have a mooring in Arctic, because it is not coming in this purview. I have just located that away from, because it is so far from this location. It is at 78 knot. So this is our strength. And this shows the schematic of various buoy systems maintained by us. The first one shows, this first left column shows the Omni buoy systems, wherein all the atmospheric parameters are measured, ranging from solar radiation, air temperature, humidity, air pressure, everything is measured, and surface temperature, surface salinity, surface current speed and direction, and subsurface current speed direction, and subsurface conductivity, temperature, pressure, up to a depth of 500 meters is measured. So this network is well established now, and due to this, we are getting the timely cyclone warning from the IMD. All these data are shared with the IMD and INCOIS and other stakeholders for precise warning during cyclone, storm surge, and other natural calamities from the ocean. And the second one is a basic medbuoy system, which doesn't have much of subsurface sensors, but it is meant for only surface and meteorological parameters measurement. And the third one is for tsunami detection application. So this video just shows a glimpse of how we deploy the system in ocean and how it is measuring the data till 500 meters. So this is how we drop the buoy systems from the ship. And then I'm just showing this clipping to emphasize, like, maintaining an air quality sensor in land is a bit easy compared to thinking of putting an air quality sensor in a platform which is very dynamic, which is moving, and sometimes it is subjected to cyclonic condition, and generally it is not stable. And the left column shows the underwater footages, like how the movements will be. Like every time it will be jerking, it will be ramped, and all these our systems are designed as per the military standard certification, so that it sustains the system even in harsh weather condition. So I want to emphasize this one before getting into our augmentation plan of adding air quality sensors. So this slide shows what is being generally measured by the SAFAR system, that is system for air quality monitoring and forecasting. So they measure again the same parameters: SOx, NOx, ozone, benzene, toluene, particulate matters, and everything. But they have a kind of a lab setup in the metros, which I was mentioning before in the previous slides. So they have a well set up laboratory for measuring this one. So their ranges are very good, and the resolution drift is very less. The resolution is very small, and it's ideal. I could say it is an ideal measurement conditions. But again, up there in the buoy systems, which has a limited power, and it is tend to move and they tend to ramp up, as I shown in the previous slide. So we cannot have such sophisticated sensors in the buoy systems, because we cannot power up the sensor, and also the sensor has to be very small in size to mount it. So below panel shows our proposal. Like we are planning to use mostly electrochemical sensors, a kind of MEMS-based sensors which are available in the market. And then for particulate matters, we are planning to use light scattering based sensors. So all these sensors are not directly available for oceanographic application, but we have to do a lot of engineering activity for converting these sensors suitable for our application. So this shows this one. And presently, as I have already mentioned, the left panel shows our present sensors. So we are planning to augment an air quality sensor along with the buoy system, so that we have the real-time air quality measurement also from the buoy systems, because we already have the network. So that will really boost or complement like how they, for example, Safar is projecting the forecast value based on their measurements from the land. But if we complement them with our data from the ocean also, definitely we suspect some improvement will be there. So in this aspect, the middle panel shows our proposal. That is, we are planning to mount a sensor air quality package as a package, because we don't want to disturb our present system. So as an add-on module, we are planning to put it. And the right side panel shows we have experimented with the prototype with a commercially COTS product, that is commercially available electronic products like a single board computer and a sensors and a GPRS telemetry module. And this work is presently going on, wherein we have interfaced particulate matter sensor, which are like really low cost or the commercially available versions. And with their feedback, what we are doing is we are upscaling the requirement and the modifications which are required for mounting the sensors in the buoy, which is up there, will be deployed finally in the ocean. So this can handle digital and analog air quality sensors. And then this one particularly, I would like to show, this is a joint program of, again, NIOT, INCOIS and PMEL. Their Rama buoy system, only one buoy system in the Arabian Sea and Bay of Bengal. They have mounted a carbon dioxide measuring system. It is an optical system, and they have deployed this buoy at 15 north and 90 east location. This value shows the value from April 2020. April 2020 to present, the present 2021 April. But this buoy is deployed in 2013. If I project that data from 2013 to till now, we could see a lot of gaps. So I mean to say there is a lot of challenges involved in measuring such air quality the CO2 concentration from the air. They are measuring the atmospheric CO2 concentration as well as the seawater's CO2 concentration by using a bubbling technique. So this shows a graph, and it also shows some trend during May month. Some CO2 values are higher, just from the finding I have just telling. And this shows our proposal for maintaining the buoy systems along with the air quality sensors. So the prototype will be deployed in one of the coastal location initially. We have coastal buoys at Chennai and Agatti and Andaman and also Goa we had. So we will first, as a first phase, we will deploy the air quality monitors in the coastal location, and then it will be upscaled to the deep sea location. So this is my presentation, sir. Thank you very much to everyone for your patient listening, sir.
Thank you, Keshav Kumar. It was very interesting presentation. Very nice.
Thank you, sir.
So, any questions on the?
No question from the audience.
Okay, fine. So, Keshav Kumar, I have couple of questions from your observations from your presentation. So you mentioned about the different types of platforms that is being used. What is the height actually? Height of these platforms?
3 meters, sir. From the mean sea level, 3 meters height, sir.
So all these observational platforms have got 3 meters. All are standardized to 3 meters.
Exactly,
okay.
Sir. Exactly, sir.
Okay. And you mentioned about the MARPOL 1997 Regulation Act actually.
Yes, sir.
And you were actually highlighting about the threshold values.
Yes, sir.
For the air pollutants. Is it being followed actually strictly?
Yes, sir. Yes, sir. Definitely, yes, sir. Like, say, for example, we have personally, I had experience of sailing in many international vessels, like to Norway and all. There, before entering, the port harbor master will get onto the ship, and they will actually note all the values, and it has to be recorded, sir. They are monitoring, sir.
Okay, good.
Yes, sir.
And you mentioned about the the reduction in the speed of the ship, which is also called as a voluntary ship speed reduction, which accounts from the biofouling activities.
Exactly. Yes. Yes, sir.
So are you thinking about any plan of optimum ship routing or something? Because that is being used, optimum ship routing. There's
exactly, sir. Yeah. Definitely, sir. As you said, optimum ship routing also will help in achieving.
I think it's not yet started in India because the program has not yet started. Yeah.
You are absolutely correct, sir. Yes.
Yeah. And in the last slide, you're mentioning about the real-time carbon dioxide measurement in the Bay of Bengal.
Yes, sir.
Both the seawater as well as atmospheric carbon dioxide.
Yes, sir.
So you mentioned some of the gaps in the profile that you're showing. So what are the reasons why these gaps have come up?
Actually, sir, to be very precise, for the past 1 year, data was perfect, sir. There was no gap. But 2013 till now, there were a lot of gaps because the system is very complex, sir. They use Lycor-based optical sensor. So because sensor is an optical stuff, so you have to pass the gas inside it. So they have pump, and before making measurement, you have to calibrate the sensor. So they have a separate cylinder of reference CO2. which is a span gas assembly. So before taking measurement, they have to span it and then calibrate it. Zero setting has to be done, and then this has to be done, sir. And importantly, the seawater CO2 measurement is a bit complicated, sir. They will bubble the seawater, and then from the bubbled concentrated air, they will again pump it to this sensor. So I want to say a lot of motors, pumps, gaseous valves and everything is utilized. That is the reason for that problem, sir.
Okay, thank you. Thank you very much, Keshav Kumar. It was very nice presentation. Yeah.
Thank you very much, sir, again.
Thanks.
Yes, sir. Yes, sir. I'm unscreening. Sir.
Okay, so now I will go to our next presentation. The next presentation is by Ashwani Vishwanath. And the topic is ocean observation buoy powered using wave energy. Ashwani Vishwanath.
Thank you, sir. Am I audible, sir?
Yes, you're audible. Yeah. You can please share your slides. You can make it the full screen mode.
Good morning, Chair. Good morning, session coordinators. Good morning, participants, and good morning, general audience as well. I am Ashwani Vishwanath from NIOT, Chennai. And today I have to talk on the development of the ocean observation buoy that is being used to, that is in operation in for some time, and which is powered using wave energy. This is first of its kind of development in India, and also rarely have been used elsewhere. So I could just give a background of this development. Top right, you see a solar powered navigational buoy, which are, you can find them in the port channels, which are used to mark the channel left and right side of it, so that the ship can pass through and go exit out of the port conveniently without any disturbances. So during the day, they are act as a marker channels, so you can, the pilot can see and move forward and backward, and during the night there is a lamp that is powered using solar energy, so that make it during the night this serves the purpose of the for the light. So we had a thought of this when we did at various wave energy development studies. So we come up with a similar configuration of the buoy, which is called a wave powered navigational buoy, which you can, and the height and the light, the marker lamp, everything remains the same, but only the wave energy is used to power the lamp. This is a system that is based on oscillating water column principle, wherein the floating body and the turbine will play a role. The pneumatic efficiency converted by the floating body in the OWC will be passed on to the turbine. The turbine will convert into mechanical shaft power, and then the electrical generator converts into electricity. We have advantages for this system because it's an all-weather wave navigational buoy, so that you have waves 24/7 as such, so that we can have the power available all throughout the day. And going further, we have found that it produces sufficient energy. So with that available energy, we are able to power not only the lamp, the oceanographic sensors as well, that I will talk about later. We have carried out a series of studies to come to this product. As you can see, right from the left to right, it starts from the CFD development of the turbine. The motivation was a backward bend ducted buoy that was developed by NIOT earlier, and then series of lab tests in the IIT Madras for the power module, and then in the wave flume studies for the buoy scale model, the CFD studies for the numerical studies for the generating the pneumatic power in CFD, and then finally various series of sea trials. This gives a picture of the navigational buoy components. You have the floater, that is the top portion, and then the spar, which is the OWC. This one, basically the water level line goes up and down here, which generates sufficient pressure to run the turbine, which is fitted at the top. So the turbine, we have a unidirectional turbine that is on the left side and the bidirectional turbine also on the right side. But right now we are using the unidirectional turbine, which is of 196 mm in diameter, made up of polycarbonate, so that it withstands for a longer duration in the sea. And the diameter of the buoy is 3 meters, and the displacement is around 4.7 tons. We have used a generator of PMDC of power rating of 180 watt. We had carried out deployments, sea trials for 3 years, from 2017 to 2020, which each stage modifications with the mooring system, with the sensors, with the turbine. So we have cross-checked all the parameters, and here we have a product. So this was deployed off KPL, that is Kamaraj Port Limited in Chennai. It is deployed at 18 meters of water depth in the navigation channel of that port. Here you see the picture of the buoy, how it was lifted and towed to the site. The location here shows the buoy where it was operation for some 1 year or so. So right now it is under maintenance, and we are going to again plan to deploy it to the same place. Now, what the additional features it has done is, it has also given us the, since the power generation was more, we have added sensors like the water currents and wind sensor. These were asked by our KPL authorities to augment the existing navigational buoy. So as such, we have put those sensors, and we have got we get data on at every 1 hour through GSM communication, as you can see in the right hand side. This data is being transferred to the KPL signal station for their own monitoring of the local conditions, as well as to us. We also have the same, but albeit in a bigger data, that is 1 minute for every 1 hour. We get a file which gives the full detail of the parameters that are logged, that are transferred to our NIoT FTP site. Coming to the electrical part of the communication, those are transferred using the data logger IoT gateway that you can see here, and then through the GSM it comes to us, and through GPRS also a full file of in the FTP server. Here you can see the voltage that was recorded of the battery that was deployed. It continuously maintains above 12 volt, indicating there is a continuous charging and discharging of the battery using the wave power. And the right hand side shows a power snapshot of some particular time series. We have generated up to, in the higher wave seasons, we have generated up to 800 watt as well from the same machine. But generally we have a low wave climate in Chennai, so it can hover around 50 watts as well. So you can here see the power budget. The major part is the embedded controller that consumes the half of the power budget, and very slightly is the navigational map. That gives us the window for operating various sensors. Here we have used the wind and the current sensor, and also we are logging the different voltage and current transducer to see the performance of the whole system. Here is the energy generated, you can see via throughout the months. We find a larger energy capture during the July month, obviously due to the monsoon season and high wave climate associated with it. Yes, this has been explained. Here you see, now this was primarily a navigational buoy, but we have modified into an ocean observation sort of buoy, which can give the local in situ data to the port on a regular basis. So these are some time series data of the wind speed and the wind water speed that was logged from the device, and that was transferred to KPL authorities. Here you can see the monthly wise data that was logged measured by our wind sensors atop our navigational buoy. And these are some diagrams for the water current and its speed. And also we have the sea surface temperature You can see that that varies also with time to time. And yes, so we have concluded that the present navigational buoy can be used as an observation buoy in the coastal areas. So since the power requirement of the ocean observation system with these sensors were found to be lesser than the total power that can be generated. So we feel that it can also take out these sensors listed over here. So out of that, we already have water current and wind and temperature. And now we are going to try with the air pressure that will include. And eventually we will put all the sensors and check for its performance. So right now we have already done our trials with most of the sensors listed here. Additional sensors will carry out in further studies. Now this is the buoy picture we can see in the off KPL. And currently the features are listed here. This technology also has been transferred to the industries a couple of years ago, and we hope that there will be a more proliferation of the technology for this application as well as for the port applications. Thank you.
So, thank you, Ashwini Vishwanath.
Thank you, sir.
For the very good presentation. It's very nice presentation. We have any questions?
Sir, there is no questions from the, no, there are no questions from the audience.
Okay. So Ashwini, I have a couple of questions about your presentation. You mentioned about the buoy which has been with the diameter of 3 meters and a displacement of about 4.7 tons.
Yeah.
Right? So is it the indigenously developed buoy actually at NIOT?
Yes, sir. This is indigenously developed by NIOT and has been appreciated by the global community as well. And all the sub-components, including the power module turbine, were developed by NIOT.
Very good, very good. Does the system actually works during all the season? Because, and what is its maximum efficiency?
The system works in all the seasons, are provided there is a wave climate associated with it. But when we see that there are certain times where the wave condition is not at all there, so there the battery plays a pivotal role. We can the battery can go up to 15 days without charging. So there and that has already been charged by the wave power before. So at a stretch, it can sustain 15 days, and then at least the wave height of at least 0.6 meters of HS should be there to charge it again.
Okay. So what type of wave heights are required for this minimum wave heights?
Yeah, as I said, it is 0.6 to 0.7.
0.6.
Yeah. Its natural period is around just about 3.5 seconds. So that is also prevalent conditions of Chennai. So around 4 to 5 seconds. So nearly that we match that, and thereby you can have with 0.7 or 0.6 meter HS also to generate.
Okay, if it is 0.6, 0.7, I think it can be put in many other sites in India also. So are there any plans for deployment in other Indian sites?
Yes, sir. We have our proposed plans for deploying 4 navigational buoys, ocean observation buoys in Andaman and Nicobar. Already the administration has asked us to do that, and a few proposals are still in the pipeline with Lakshadweep administration, and some other ports which are often which actually approach us or we approach them. And there are industries involved also, so they can also proliferate this one.
Okay, very good. So my last question, actually, I think it was in your last slide that you mentioned about you've tested with waves and currents.
Yeah.
And now you have a plan of doing it with the air pressure also.
Yes.
So how efficient is this air pressure?
What are the port authorities has asked us, like when you have integrated already, they want a local in situ measurement for at regular intervals.
Yeah.
So for that, they had asked initially for the water current as well as the wind velocity. and with the air pressure, that will augment them to see the environmental perspective in a larger way. So they asked us to do with the air pressure as well. But eventually we feel that with the power that has been generated, we will be able to encompass most of the ocean observation systems in coastal region.
Very good, very good. Very good, actually. I'm very happy with your presentation. It was a nice presentation.
Thank you.
Thank you very much, sir. Thank you
very much. Thank you, everyone.
So now let us go to the next presentation. The next presentation is by Praveen Kumar Kar. The topic is erosion and accretion pattern and shoreline changes near Gopalpur Port, east coast of India. Good morning, Praveen Kumar. Yeah, you can just share your presentation. Yes, yes. Yeah, it is visible now. Yeah, you can please start. Yeah. You're not audible, Praveen. Your voice is you're not audible.
Praveen, you are muted.
Yeah, yes, now it is okay. Now we can hear you. You can go to the first slide. Yeah. You can put it in the full screen mode. Yes, it's fine. Yeah. No, we are unable to hear you. The voice is not audible. Prabin, I think we are unable to hear you actually. Your voice is not audible.
Yeah, please increase your voice level. I think it's voice level is very down.
I think there is some problem with your voice. We are not audible.
Praveen?
Yes, Josiah, you're saying something? Yeah, slides are visible, but the voice is not audible.
Please check the connection of your microphone. Or we can take the another presentation.
Yeah, we can. I
and
think
then
we can take the next presentation. I think
after that we can. Yeah, then you can check. Meanwhile, you can check your mic connection.
Yeah, you can check your mic, Praveen. I think some problem with your microphone. You please check that. Yeah, no, it's not audible. Okay, so then we'll go to the next one. I think Praveen can come after some time. We'll go to Bishwajit Haldar. The topic is effect of mooring motion on temperature profile measurements in the OmniBuoy systems, a case study.
Yes, sir. Am I audible, sir?
Yes, yes, yeah, audible.
Yes, Vishwajit, you are audible.
Yeah, you can make it the full screen. Bishwajit, you can make it full screen.
Just 1 second, sir. How to make it full screen?
Yeah, you can just click on the button on the bottom. That's a full screen mode. Yes, it is fine. Absolutely fine. Yeah, please start.
Okay, so good morning to all of you. So I'll start my work. This is effect of mooring motion on temperature profile measurement omnibus system, a case study. Basically, we have taken a particular case for study. So this work is carried out by myself, Abhishek Tandon, K. Joseph, Farul Muthaya, P. Sendil Kumar, and R. Venkadeshan, our group at Ocean System, National Institute of Ocean Technology, Chennai. So this is the overview of my talk. This is a standard like introduction, instrumentation, data processing, temperature remapping, then result, and acknowledging references. So before starting the main thing, so I want to just tell about what is the importance of temperature profile measurement in subsurface ocean. As all of you know, that like there is a temperature variability in the mixed layer, and upper thermocline plays a significant role in the operation dynamics and affects the weather system. So ocean temperature profile measurement is also important to understand the dynamics of global climate and marine ecosystem, especially the ocean heat content from the surface to the depth of 26 degrees Celsius term, that is D26. That is known as tropical cyclone heat potential, has a major influence on the tropical cyclone intensification. So in this mandate to measurement of the for this meteorological as well as subsurface parameters, NIOT is maintaining the 12 omnibuoy network. This is also moodbuoy network, North Indian Ocean. So I won't elaborate about the omnibuoy system and all, that is already explained by my colleague B. Kesav Kumar sir. So the subsurface, basically what I want to emphasize, our omnibuoy having the subsurface temperature measurement up to 500 meter depth at different discrete depth, 12 different discrete depths, and the 500 meter all are conductivity and temperature measurement, and 500 meter having the pressure measurement. So this subsurface temperature measurement actually like it is subject to change because of the upward movement of the mooring line, and this is forced by the wind forcing and current forcing and the wave forcing. So I want to I am interested to find out the changes of the temperature measurement because of mooring motion, and for that particular region, this is our sorry. So you can see this is the our buoy network, and there is this also I won't explain what are the buoys there, as you already sir explained: omnibuoy, coastal buoy, midbuoy, and tsunami buoy. And I am interested, I have taken for this particular analysis like BD13 buoy location. This is actually in the central Bay of Bengal. Now the question may come, why I have chosen this location. Basically, as I told already, normally our buoy having only one pressure sensor is 500 meter depth, but this BD13 location having total 5 pressure sensor at different depths. And I have chosen this BD13 location, and this having 10 meter, 50 meter, 100 meter, 200 meter, as well as 500 meter pressure sensor. The duration is from February 2015 to January 2016 period, around 1 year period. This is the schematic of the omnibuoy system, as you can see, and that there is a 0.5 meter CT, and there is 1 meter CT at the keel frame, and there is a 5 meter CT at the ADCB frame, and below there is like 10, 15, 25, 75, and 100 meter, and 200 meter, and 500. So as I told, 200 500 meter having only CTD, the normal standard omnibuoy configuration. So here, this is the induction cable, up to 500 meters. Then there is a nylon rope, and that is up to surface floor. There is 750 meters. Then after that, there will be PP rope, and this catenary shape. Actually, our mooring is this is slackline mooring, and it's obvious like slackline mooring having some advantage and disadvantage. As the advantage, we may see like slackline mooring having like for the cyclone and all, it will take care. Like the buoy will be sustained during the heavy cyclone and other things, but the disadvantage means because of this extra 1.2 mooring scope, it will free to move within the 1.2 scope, and there will be, that's why the mooring line may not be totally vertical all the time. During the extreme weather, it will be make a slant actually. So we are using this SBCT sensor for our particular temperature and conductivity measurement, and this having the option to measure the pressure also. So this CT sensor having like 7,000 meter, as you know, dynamic casing, and also this CT sensor having the accuracy of 0.002 degrees Celsius, and temperature accuracy, and the pressure accuracy is 0.1 degree, 1% of full scale value, that is around 1 meter for the 1,000 meter depth rated pressure sensor. So we are not considering for the analysis any dip like dip due to its time. So as we studied already in the earlier study by Venkatesan et al. 2019, it is clearly shown that the dip is 0.012 degrees Celsius and 0.002 degrees Celsius in Arrowance and wave angle, and which is, if you see the accuracy is 0.002, this is comparatively very less to the accuracy. So I have not considered any drift the error because of drift in this analysis. So we are using 1 hour data as this our buoy having internal records of 1 hour. So every 1 hour it is recording internally all the parameters, and it is transmitting 3 hours to our data reception center. So we are using the internal data, like retrieve data from the buoy, and already sir explained what is the difficulty in retrieving other things. So next is like temperature remapping. Now the question is, I mean, okay, temperature remapping, how we are doing the temperature remapping? That is the main important question, you know. So temperature remapping, basically we are using one pressure sensor as 500 meter initially, and by using the pressure sensor, we are trying to estimate the depth, actually the depth of all other 11 CT sensor by using that one CT pressure reference. So in that angle we did, and these steps, and you may there will be definitely a question how you can assume a straight line from 500 meter 100 meter. The mooring is not straight, so that's why we have chosen this VD13 location. As I already mentioned, they are having total 5 depth measurement, 10, 50, 100, 200 and 500 meter, and by using these 5 depths, it's actually true depth, so we are getting estimates of other sensor depths from the interpolation, not linear interpolation. And once you get the depth of each and individual sensor, then you can definitely find out the depth of the other sensor. Once you find the depth of each and every sensor, then you know what is the depth and what is temperature. From there you can interpolate to your desired standard omnivore depth, what is the temperature. And then here I am showing in this slide, like there is each and every pressure sensor, you can see mean standard deviation, RMS deviation from the actual depth. And it is clearly showing if you go to 500 meter depth, there is 32.65 meter deviation, mean deviation for the 500, and it is 10 meter for 10 meter 0.21. So it is clearly stating that if you go down deeper location, your mean deviation from the standard deployed depth will be more, and that is obvious because of your mooring design, slackline mooring. So this is the result. I am here in this graph. You can see this is delta T. So what I did, I have calculated the difference field, temperature difference field. That is the actual temperature and the remap temperature. So difference field I have calculated, and this org exercise I have done by considering first I consider only 500 meter pressure sensor. Then I have gradually incremented like 500, then 500, 200 meter pressure sensor I have used for remapping, and then 500, 200, 100, like that I have gradually incremented as I have total five pressure sensors for this particular location. And then I have plotted the difference field. So in this graph you can clearly see, when I have considered only for 500 meter, there is a second, apart from 500 meter, there is a second temperature peak at the 75 meter to 100 meter. So this is why it is coming. No, it is very obvious. Like in the 75 to 100 meter, there is like there is a thermocline zone, and in this case there is temperature different. Temperature like slope is very high. So small difference in the difference in the depth will give you huge difference in temperature. So in order to address this, so this location, once by one, if you gradually increase the pressure sensor, finally, if you see this green line, this is a final line, and it is showing like almost straight line. And once we add after 500 meter 200, there is no that much difference, because you can see in blue line and red line. But once you add 500, 200 meter and 100 meter, then you will get a reasonable straight line. So what from this we can interpret, and the thing is, you can see in the table also, the 100 meter in the 100 meter depth, the temperature difference was 0.44 degree Celsius. When I consider only 500 meter, it is drastically reduced to 0.03 when I consider 100 meter pressure sensor also. So and similarly, you can see in the 50 meter also 0.27 drastically reduced to 0.03. So this is actually giving idea. So with 500 meter, at least one more pressure measurement at 100 meter to get a correct estimate of the temperature difference field. So this is the summary. So what I already explained everything. The error of profile measurement due to the slack line mooring is analyzed in details, deploying OmniBuoy with the additional depth measurements for discrete depths level apart from the standard measurement 500. It is observed that the maximum variability in the depth and temperature is at 500 meter. The deepest profile measurement of OmniBuoy system or line experience a greater range of motion. Secondary peak in temperature variability is observed at 75 100 meter, which falls under the upper thermocline region. Since slight change in depth introduces a large gradient temperature, already I explained. The size of this correction underscore the need of corrections in both real-time and post-deployment processing. It is also found that the actual depth variability and the corresponding temperature variables are much less in the lower depths, and it is like meager in the depth up to 75 meter 0.01. And it is reasonable at 200 meter and 500 meter. The study reveals that the necessary and additional depth measurement at 100 meter apart from the standard depth measurement 500 meter, which can be utilized in the correct lower measurement of the OmniBuoy system. This is acknowledged. So I really like to thank Minister of Science, Government for funding this Ocean Network, and member of National Students Committee for leading this program, Director NIOT and NCA for Goa. Thanks for providing all the facility and support. I'd like to thank my group head, Dr. R. Venkatesan, for continuous support and encouragement of this carry out this work. And I want special thanks to all the co-authors to share their ideas and valuable session for this work. Also thank to staff of Ocean System Group, Vessel Management Cell of the NIOT, and chief staff for their excellent help and support on board. This is the references I have used to carry out this work. Thank you.
So thank you, Bishwajit Haldar. It was very interesting talk. Very nice.
Sir, there is no questions from the audience side, but I have a question.
Yeah.
It was a very good, very excellent presentation, Mr. Bishwajit, and I'm sure it will add on. It has a significant contribution when you are thinking about the OmniBuoy network, because we are operating it with only 500 meter pressure measurement. So you have carried out this work with many pressure measurement in between. So what is your final suggestion like? Apart from the 500 meter, are you going to continue with multiple CTD measurements, or any one or two add on?
Yes, ma'am. As I already explained in my presentation, so apart from 500 meter, if though we are maximum, like the researchers and oceanographer, they are more keen to the upper layer thermocline zone and all. If someone is really interested to work on deep ocean 500 meter, that is pressure sensor already there, so that can be calculated or corrected. But 200 meter and all, we need definitely one more pressure measurement, at least 100 meter apart from 500 meter, to get an corrected temperature measurement.
Thank you, Mr. Vijay.
Thank you, ma'am.
Yeah. So Bishwajit, I have a couple of questions.
Yes, sir, please.
It was a very good presentation. Your study basically considered the 26 degrees isotherm, no? D26.
Yes, sir.
For the estimation of the tropical cyclone heat potential.
Yes, sir.
And of course, definitely, as you said, that it has got a direct implications on the intensification of tropical cyclones.
Yes, sir.
Now, this 26 degrees isotherm has been documented as well as being used in many places. But today, due to global warming, I think they have corrected it as 26.5. There are some studies which says 26.5 should be taken instead of 26.
Yes.
So what are your views on this?
Yes, sir. Actually, really, they have done the exercise, and it is definitely come out with the point means we can definitely follow, and our exercise whatever I have done, and we can, our calculation also can be done like 26.5 degrees Celsius. As this came later, I am not included. Really, I am sorry that I not in taken that like 26.5.
No, but you can look. You can look actually, because 26.5 is now, because there's a global warming also which is coming up in all the ocean basins. So
yes, sir. Yes, sir.
Maybe you can use it as a future scope of your study actually. That will be really
surely, sir.
The second question what I have is the maximum variability in depth and temperature you're observing at 500 meters.
Yes.
Which is the deepest
measurement
of the omnivoice.
Yes.
So now, according to you, what are the physical parameters that play a role at this depth? Physical parameters.
So to get this huge difference, you are telling?
Yes.
So basically, first point actually your our mooring design.
Yeah.
So if you see, this 500 meter is the lowest point of this 500 meters induction cable, and it is a slack line mooring.
Yes,
so when your buoy is moved horizontally in the surface, and when definitely when it is moving in the horizontally, and if you make a slant line, so you will feel that bottom point will come maximum upwards. So that is one point. Like because of the mooring design, it's coming the maximum upward movement is coming in the lowest depth. I don't think any other factor is there for this huge variation in the lower depth. That is the main point actually.
Okay. So basically, you're attributing it to it is due to the mooring line.
Yes.
The mooring line is playing a pivotal role here.
Yes.
Okay. That's good. Very good. So these are my two questions. Thank you very much.
Yeah, thank you so much, sir. Thank
you. Sir, can we have a break for tea?
Yeah, we have a 15 minutes break now. But let us say we can ask Praveen Kar actually to join, because he had a problem with his audio.
Yes.
So I think we can have a break, maybe a quick break of about 10 minutes. 10 minutes is okay, no?
Yes, sir. Yes.
So in the meantime, I think Praveen can actually check his audio connection also, whether he's able to. Yeah. Yeah, Praveen, I think is here. I think Praveen can actually check whether his audio is working, because yeah, if it's then we can start actually with Praveen's presentation, the next presentation.
Okay. So I request all the participants need not to leave the platform. They can remain muted, and please rejoin at 11:45 sharp. We'll start with Praveen's presentation.
Yeah, that's fine.
Mr. Praveen, can you check your mic? Hello, Mr. Praveen.
Positions, we can tell that now this system says as per design condition it is generating power, and these are the few pressure sensors were used for low pressure, which are actually 0 to 2 millibars and all are actually different. These are the sensors actually are required, right pressure sensor to be implemented, and this is one of the critical things because it is a multi-phase flow. And also for performance,
you have one more minute.
Okay, ma'am. I will complete it, ma'am. Okay. And these are the actually that data actually real-time performance assessment was done, and based on pressure sensor, almost 50% of data are actually means estimated, like enthalpy, pressure drops, freshwater yield calculations, heat input, all everything. So this is the actually how the system was improved. Previously around 140 to 150, and now we are generating 1 kilowatt. And this is the actually design systems plant is was designed, and now we are getting in laboratory. And you can see that actually, sir, a sensitivity analysis was done. That one also in flash chamber pressure, there are 1 millibar change in the pressure. Almost there are 20% of change in power, and around 20 to 30% change in freshwater will be there. So the pressure measurement, the most important things. So I can conclude that it is the first type of laboratory implemented in India, and this instrumentation system are deployed, and also the understanding this pressure measurement will be useful to because if you use only pressure sensors, fluids, things, so very compact and low cost data logging system can be developed and it will be implemented for island plants. Thank you.
So thank you, Biran, for the very interesting presentation. It's very good, very nice presentation.
Sir, there is no question from the audience.
Okay, so Biran, I have a couple of questions. Like
Yes, sir. Yes, sir.
You have given a demonstration, very good demonstration about the NIoT OTEC LTD lab test facility.
Yes, sir. Yes, sir.
So you come out with a new concept of how we can use the pressure variations, basically the OTEC power plant.
Yes, sir.
And the potential of using this power plant in Kavarathi.
Yes, sir.
So how much of power actually we are expecting from this, generated from this plant?
Yeah, from Kavarathi, sir. Kavarathi, we are expecting around 65 kilowatts, sir, around. And it will be actually the motto of this plant is actually to make self-sustained desalination. So there will be 1 lakh liter capacity desalination plant will be there. That will be run from this power generated. So that is the motto.
Totally 65 kilowatts.
Yes, sir. Yes, sir.
Okay. What are have you planned for any other potential locations in India other than Kavarathi where this plant can be used?
Sir, that was actually already means already literatures are there and also were done, but it is first thing is the main demonstrative. Sir. Till now, OTEC plant was not put actually. After that is the important thing, sir. If we put once there, then there are we have how you put desalination plant in Lakshadweep itself. There are actually 3 places there. So basically, it will be very good for island place where actually thermal means will get cold water near to source. Sir. That is the important things. That is another one of the challenge things. No, sir.
Very good, very good, very good presentation.
Yeah. Yes, sir. Thank you, sir.
Thank you very much, Biran.
Thank you very much, sir.
So now let us go to our next presentation. That is by N. Ramakrishnan. The topic is on long-term shoreline changes along the Kanyakumari coast using geospatial techniques.
Sir, good afternoon, sir. Am I audible?
Yes, good afternoon. You are audible.
Yeah, thank you. Hope my presentation is visible now.
Yes, it is visible. Yeah. You can make it in the full screen mode.
Yeah, yes. Thank you. So very good afternoon to one and all present here, and special thanks for the chairperson. Myself, Dr. Ramakrishnan. I'm a functional area expert in land use in Indomo-Coastal Hydraulic, Chennai. Now I'm going to talk about the long-term shoreline changes along the Kanyakumari coast using geospatial technologies. So this geospatial technology is nothing but a GIS and remote sensing. Here, nowadays, there are a lot of improvement has been taking care of this GIS and remote sensing techniques. So with the use of these techniques, how the shoreline over the period has been changed, those part I'm going to talk about here. And also I have been discussed about the coastal villages shoreline change. Now, the shoreline as the contact between the body of water and land is an interface that continues changing through time space, while shoreline is an actual margin of two coasts, includes the area below and above the waterline. It's an sorry, kindly mute, Mr. Yeah, thank you. The present study and attempt was made to elucidate the aggression and erosion site from the multi-temporal satellite images of Kanyakumari district coast, Tamil Nadu state over the period of 30 years. Here, the study period is 1991 to 2020. That means 30 years of changes I'm going to display in this presentation. Before that, I just want to give a small note about the Kanyakumari district. That based on the agroclimatic and topographic condition, the landform of Kanyakumari district can be divided into 3 region names: uplands, middle land, and lowlands, as it bounded with the patches of Western Ghats. Whereas the upland consists of hilly and valleys, and midland consists of plains, and low consists of the coastline region. Here, the overall stretch of Kanyakumari coast is composed of sandy beaches with the intermittent presence of rocks at Kanyakumari, Mottam, Kolachal, and Inayam. High sand dunes are present in the Periyakadu. More than 60% of the stretch is built with the shore protection works like seawalls and groins, mining of the basin to Manavarakku. Here, these are the important salient future I'm going to discuss about. As you know, the study area is Kanyakumari district, district coast. Materials and method, what I'm going to use here is the satellite imageries and visual interpretation techniques, and the result and observation I'm going to show you. And this is and most important thing is coastal erosion and aggression along the Kanyakumari coast. This is the most important section which we are going to, and also the future scope. What are the things we can implement in future? That also we are going to talk about this presentation. Yeah, this is the study area. The Kanyakumari, as you know, this is the 70-kilometer coastal stretch approximately here, and the coastal segment of Kanyakumari district is bounded the lat long of 8 degree 08 minutes to 8 degree 17 minutes, and the longitudinal is 77 and degree to 5 and to 77 to 36 in the eastern part of. The coast belt extends about 15 kilometers of eastern side, bordering Bay of Bengal with combine of Indian Ocean, as well as 55 kilometers of western side bordering is Arabian Sea. As you know, this picture here, the most of the coastline is spreaded in the Arabian Sea. It is adjacent to Kerala. The southernmost tip of Indian mainland is Kanyakumari, as well known as it is a tourist place activities, which is aesthetic view surrounded by the tri-seas. As you, this most important place in India. There are the tri-seas like Bay of Bengal in the east, Arabian Sea in the west, as well as Indian Ocean in the south. We are talking about data here. I carefully have been chosen the data because there are a lot of data are available in the open source, but the cloud free is most important. Therefore, accordingly, I have been specified my categories. Here, the cloud free Landsat satellite imageries have been used. The section like 1991 multi-spectral scanner, that is MSS Landsat data, as well as that in 2000 I have been taken off thematic mapper. In 2013 as well as 2014 I have been used for thermal infrared sensor, that is mean TIRS. Both have been Landsat data. Now, for your better picture, I have been shown in this. See, this is the satellite imageries. The first one is the multispectral data 1991. Thematic map is 2000. Here, 2013 and 2020 I have been used for thermal infrared sensor. Sir, talk about the methodology is most important for point of in every presentation. Here, the detailed study, as I said, in 1991, 2000, 2013, as well as 2020 is a cloud-free data have been taken. Those data have been adapted. The common pre-processing and procedure of atmospheric correction, radiometric correction, and image enhancement were made. The high water line is considered as a shoreline and digitizing manually. Here I have used visual interpretation method, and the polyline is the geodatabase shoreline was applied in the DSAS, that means digital shoreline analysis system. This digital shoreline analysis system is an extension tool of our map software that computes the rate of change statistics from the multiple historic shoreline position in the present GIS. The DAS model generate transect line automatically in the perpendicular to the baseline and across the shoreline based the specific space of an interval. The transect shoreline intersection along this baseline are then used to compute the rate of changes in statistics. Finally, the report rates are expressed as the meters in change along the transaction per year. Those part clearly I have mentioned in the upcoming slides. One by one I'll show you. Here I have used the method like endpoint rate method. That endpoint rate method is mostly you scientists and researchers they are using for the shoreline changes. Here the endpoint rate is nothing but the calculated by the dividing the distance of shoreline movement by the time of elapsed between the oldest and the most recent shoreline. Major advantages of this EPR method to computers minimal and required for only 2 shoreline. If it is more than means, it's more good. So there are disadvantages also there. So with that, I'm going to start my output. Here, as I told, 1991 to 2000 and 2013 to 2020 as well as and final is 1991 to 2020. All together again segregated in 3 sectors of map. The map number 1 dividing into first category is 1991 to 2000. Here, when you see this Arabian coast, this portion, there are 55 kilometers of stretch. When you see here, it is a medium and at the border end. This means the very, very medium of erosion occurred in this particular year. And the accretion of Muttam, that means the box clearly shows that it is kind of headland, that aggression has been happened. As well, similarly, the most important thing which we want to notice, that is Bay of Bengal side, it's getting kind of aggressions. That means most erosion portion has been laid in the Arabian Sea, and the aggression portion has been occurred in the Bay of Bengal side. That upcoming slide we can see. And this is most crucial part of that present study, because when you see here 2002 to 2013 and 2000, this is the most important, because that 2004 everyone knows that tsunami was occurred. When you see here, after that tsunami, there are drastic coastal morphology changes in this Kanyakumari coast. You see here almost 210 meters of the border area. That means Arabian Sea has been eroded towards the land side. That means heavy erosion at the border, heavy erosion at Muttam headland, as well as the similar morphology. When you see that Bay of Bengal side, it's kind of aggression in the cave. You see here 2013 to 2020, again the coast is come back to the normal mode. When you see this particular decade, that means 2013 to 2020, it has kind of very small erosion and aggression happen in the similar pattern. So now I'm going to give the overall structure, that means shoreline assessment. When you see this picture, it's clear-cut note that is there is a huge erosion occurred during the period of 2002 to 2013. Because of that, the reason is tsunami and other disasters has happened in that particular decades. And here you see that now in this particular right hand side picture, when you see erosion as well as aggression happened, the complete erosion is Arabian Sea side, and the aggression has occurred in the Bay of Bengal side, sir. So here and not only that, now the study also have been included the coastal villages mapping. That also I'm going to show in the upcoming slide. Now see the result of endpoint rate, that means DSA, digital shoreline analysis system output. You see here there is similar pattern has been occurred. You look at that green, that kind of erosion, and red color it shows as an aggression pattern. Yeah, now we come to the graphical representation point of view. This graph representation is rate of changes between the overall and selected years. Why the the changes? But due to the very rough sea in the monsoon and the shore, the shortfall in the littoral sediment from the Kerala side, and peninsular part of the Kanyakumari is undergoing the severe erosion, as well as that particular decade that you see this gray color line. It because of the tsunami impact, also one of the most important point. Now I'm going to give a clear-cut view about, because based on the result as well as the field verification of the village assessment, I am given this particular table. In this table deals with what are the coastal villages available in the Kanyakumari district, and what are the coastal it's prone to that erode and high erode, low erode, as well as stable coast, as well as in addition to this study area. And I have mentioned government structures, because after that tsunami, Tamil Nadu government, that PWD and Fisheries Department, they have taken a lot of improvement activities, and coastal protection structure they have been constructed over the period, and that structure also have been mentioned in this particular slide. See that there are Kanyakumari that are having one kind of breakwater, and the Kovalam and Keelam Manakudi, it's called sea walls, and you see like that you have been mentioned. So whenever the people, those who are not idea about that, you can see this table, and in future also we can predict based on this. And now I'm going to explain what are the coastal villages it comes under eroding and high eroding. Now I'm going to talk about high eroding. See here, the Chota village is one of the village coastal area has got highly eroded, remaining all as low erosion. In this particular village, about 20 of our village, there is no stable coast here. Now the next slide, you see Valla village is got highly eroded, remaining all like low eroded coast, except we can say Midalam, Male Midalam, Helen Nagar, and Inayam. That's called stable coast. Now I'm going to show you kind of pictures, which is we went to the field and we directly see the particular area, how it was and how it is be. And we are talking about the local fisheries, fisher people also. And based on that, I have been derived that table. You see these slides. Kanyakumari.
Ramakrishnan,
Yeah.
you have 1 more minute. You have
sorry.
one. Please continue.
I'll come to the quick summarization. Yeah, this is a Kanyakumari Kovalam coast, stretch and Kovalam breakwater. And these are the eroded. As I said, you know that Chotavilla. See, this is the Chotavilla. This is a highly eroded. You see the road here. It is completely eroded. And similarly, there are government has been taking care of a lot of structure to prevent that that shoreline erosion. And these are the coming up pictures. Will give you the better idea how the government they have been taken care of these things. Male Medalam and groins between the Inam and the Tengapatnam, and this is Tudanur branch, and this is Nirodi, construction of seawall, and Marmatanture. And now, not only restrict this paper with that conclusion, we are planning to predict the future shoreline and identify the suitable location for protect the sea protection structure. A sea protection work like seawall, groins, and breakwater. When you see, this is the when you use high resolution satellite imager, obviously you will get a very, very good impact, but we have to pay some money for that, and we have to get it from the National Remote Sensing Center in Hyderabad. So if you use this kind of study in future, like we have a list 3 data and GI data, we have n number of data are there. So if you use, obviously we will get very, very good accurate structure we can predict where. And this in GIS most important point is synaptic view. So with within very short time period with the good resolution data, we can able to provide very accurate output in that. Also, we are planning to develop a shoreline management plan for the concerned district authority to help to improve their future activities to predict the shoreline as well as to protect the fisherman community and the other people from the shoreline change. With this, I conclude, and I thank for giving this opportunity. Thank you, and I'm very much welcome for this posting. Thank you.
Thank you very much, Dr. Ramakrishnan. It was a very nice presentation, and it was a very detailed study that you have carried out.
So there is no questions from the audience side.
Okay, fine. So, Dr. Ramakrishnan, I had just noted down some points. You mentioned about in your methodology about the visual interpretation method that you have done.
Yes, sir.
Can you just elaborate on what is that visual interpretation method?
Sir, there are two kind of techniques in remote sensing, sir. One is visual interpretation techniques. Another is auto image classified techniques. That is auto image classified techniques is computer itself it will take, but visual interpretation we can use based on the experience, based on the tone, structure, and the value of and the wetland and the snapped in tone of the satellite imagery view. We used to just draw the coastline, and based on that we can able to keep set of lines like 1990,
okay.
90, 2000.
Perfectly fine. So my second question is, what are the most significant findings that you find on the long-term changes in the shoreline? Is there a net accretion or a erosion? And whether it has got any interannual variability?
Definitely, sir. Because when you see, when the long-term shoreline changes, there is an Arabian seaside. That means 55 kilometers of shoreline as continuous eroded pattern. When you go for a cape from the cape to north, that means Bay of Bengal is getting aggression method. This is the finding I want.
Okay. So one more question. There was a very important study by Rajawat. I think you may be aware of it. Rajawat from the Space Application Center, ISRO.
Yes.
They have used a very high resolution data, the list 3 data and all, for the shoreline erosion and deposition at various shorelines along the Indian coast.
Yes, sir.
So you can also have a look into that study. Maybe that will be useful for your work.
Thank you so much.
You mentioned about your tsunami impact and the drastic effects that has caused.
Yes,
but,
sir.
That is very much true. But another important thing what is happening is in the recent days, you are finding tropical cyclones and Arabian Sea is also becoming very active in tropical cyclones.
Correct.
The strong waves can also impact the shoreline changes. Maybe you can consider it for your future study. Yeah.
Sure, sir. Thanks for your suggestions. And
Thank
I would like
to. Thank you very much, Dr. Ramakrishnan. Yeah.
Thank you.
So let us go to our next presentation, that is by Sri Ganesh. The topic is on shoreline changes of Devanagari coast in Tamil Nadu, India.
Very good afternoon, sir. I hope audible as well as my
Yes,
flight
yes.
is
You can make it in the full screen mode and you can start. Yeah.
Thank you, sir. My name is Dr. Sri Ganesh. I'm going to give a talk on the shoreline changes along Devanagari coast of Tamil Nadu in India. I am actually a principal scientist working at Ocean Engineering of IIT Madras, Chennai. This study is carried out along with the other professors of ocean engineering and guidance by one of my staff. As everybody knows that coastline is very high strategic, economic, and societal importance to the country, not only to our India, but all over the world. The coastline is richly endowed in cultural heritage and biodiversity, and living along the coast is always highly attractive. There are multiple sectors involved in these coastal zones, not only in terms of the sustainable development like desalination, ports, harbors, and industry. There are many requirement of the fishing villages, fishing hamlets, more settlements in these regions. The livelihood of the entire fishing community depends upon the coast only. So, as well as nowadays, the attraction and enhancement of the tourism is also widely important, and also many people started having their leisure time to have enjoyed shorelines. But these coastal factors, coastal zones, is having a multiple hazards which cannot be stopped. It has to be undergone. In terms of the time and the distance, it is actually divided into different scales. The geological scales, normally they used to call the sea level rise, which need to be studied for several decades of years, centuries also, how the global warming is inducing this sea level rise. And similarly, the land subsidence is under long time period scales, which need to be studied properly with the times. Again, if you come to the hydrodynamic scale, the very impacts will be very short term, but the recovery period may be a very long period, as well as the distance of impact also will be up to 100 kilometers. Similarly, the engineering protections also having their own recovery period as well as the implications. There are causes of natural erosions divided into in general, the natural as well as the man-made. This is what in generally they used to say. So what we will do is the cyclone, we cannot avoid it. We have to face it. As for the extreme ways, we can able to predict when it can come, but we have to face it. We cannot avoid it. The sea level rise, yes, the global warming, rising temperature, it has induced more inundation into the shorelines. So these are all the severe natural factors which we have to face. We have to alter ourselves to make our shorelines into a better way. Whatever the man-made developments as showed in the video, so it is also not that much sustainable for the long term in terms of the protecting the shorelines. So, but the developments in kind of the ports, damming into the river, dam construction inside the rivers, and dredging in the tidal inlets, these are also inducing some severe impacts. As well as the surface is exaggerating the shoreline modifications. Here I'm going to show about only the small stretch of the coast, which is situated at southeast India, northern Tamil Nadu, in Mahabalipuram north, about 5 kilometers. From Chennai, it is about 50 kilometers south. The picture shows that how the location, where is it. But this fishing village, majorly, why this area got selected, I'm studying this A region is, this entire fishing village's livelihood is only the fishing. And this village is nowadays, in the recent years, it has undergone to the more vulnerable to the erosion, and also as well as some of the immediate coastal protection measures as attempted, with having much details of this coast. The implementation of Tamil Nadu state government, everybody, or some other agencies, they, because of the requirement, immediate coastal protection has made. Then the vulnerability has changed in a better and in different way. So I started studying with the help of the other central government. It's one of the central government projects, how to study reviewing the coastal protection structures, what they already developed, the bottom left picture shows that the seawall just dumped the rubble mound blocks of about 40 to 50 meter length. So on what basis? How can it can be sustainable for long? I just reviewed this structure and how it can sustain for a period of some time. As well as we started monitoring the entire shoreline because the structure has come up in this village. But how much the study need to be taken care of to protect this village? Why the erosion is only in this village? So the detailed study need to be taken by measuring by using our latest technologies like RTK GPS. We applied this for the measurements. Major thing is the data collection, as everybody knows, to understand first of all what the coast is, how it looks like. So, but normally they used to say long-term monitoring is required. But here, we started the study in 2017, 18, and continuous measurement. That is not possible. But luckily, we had 3 years of data. Though we are having some breakups because of COVID, but for sure we are having some good and plenty of data in a monthly wise frequency. That too during especially the spring tide, we selected to monitor the shoreline by measuring the high tide line as well as the low tide line by using the real-time kinematic GPS global positioning system, which is having a high accurate, which is purchased especially for this project. And we started monitoring not only the HL line, LT line, as well as the perpendicular to the shore, how the beach slope is varying. That also we studied. Others also we carried out, but here I am not going to speak about that. We are going to see only here about how the HTL, LTL, as well as the beach profiles giving a good or considerable information regarding the seasonal variation of the shorelines by even annually also because of by studying this 3 years data. So first, for any survey, we required some standard benchmark, very known to everybody. So we collected the Survey of India benchmark, which is not available near to our coastal location of Devanagari, as I said, it's about 50 kilometers away. The nearest location is from Chennai. From Chennai, it has transferred using our RTK GPS by after special getting approvals and all. But as you know, that the distance is about 50 kilometers. Immediately within one stage, the RTK GPS what we procured, which is having accuracy of about the range of communication. So it is because of our network, SIM card can able to communicate with the base and rover. It could able to communicate maximum of about 20 kilometers. So based on our accuracy, we just made such a way that 15 kilometers in an RH to transfer the benchmarks from Survey of India, IMD to regional meteorological center for Chennai to our site location. The picture shows that wherever the location of the benchmarks and how we transfer the equipments. Second thing is the tide. Again, we are a little handicapped. There is no tide data near to our location. It's mandatory for further other corrections. So again, we depend on the Chennai tide. That is the nearest location could be able to get it for having to identify at least the spring tide time when it is falling to plan our surveys to execute the coverage of the high tide line and low tide line as well as the beach profile transacts. So this just one picture of the 1 month. We just showed that spring and neap. In a month of 2 springs and 2 neap it showed. But this is same followed for all the continuous for about 3 years. Every month we used to follow the same schedule. We started covering only one spring of the month. Like that, we covered about 30. As I mentioned, the monitoring methods, not only the shore parallel HL LTL, as well as the cross shore profiles, transacts we selected every 100-meter interval. As I said, the accuracy levels of our RTK GPS is maintained 5 to 10 centimeter, even in the vertical, as well as the horizontal positioning, it has made 15 centimeter. As everybody knows that there are having two communication. One will be at the stagnant, the base location, which will be continuously measure the satellite positions, and it will try to provide accurate data. And again, the other one will act as a rover, which can able to roam and it can able to collect the data. Yes, as I mentioned, it started from April 2017 to February 2019, total 23 months, and again March 2022, May 2021. Some months because of COVID, we could able to cover, but for sure that will be compensated. We just extrapolated the data and it can be changed. So this, as I mentioned, there are 7 transects, each with about 100 to 150 meters perpendicular to the shore. So each transect, the shorelines is mapped and marked over here. This graph shows that top one is transect 1, transect 2, transect 3, middle and bottom, and the months of shoreline coverages of this profile. Sorry, it's a perpendicular to the shoreline. Shows that how the beach variations is happening. The low water line, high water line, which is taken from the survey of India. We just plotted this one. What is the level of that year from the survey of India booklet? What is the MSL? As well as what is the low tide line, what is the high tide line? Those levels only we just marked here. But our survey, we started with a standard benchmark, which is we fixed it, the standard benchmark at the shoreline along the shore. From there, we normally used to start the survey regularly. But as you know that all the fixing point may not be parallel to the shore. So we need some kind of compromisation to identify the variations. So what we thought is as I said, the lowest low water can be achieved only during the spring tide time. So we used to go sometimes far into the water of more than 20-30 meters from the berm itself. The 0 meters, sometimes it can be called as a berm.
Ganesh, you have 1 more minute.
If I'm correct, I started my clock. It's now the 11th minute is running. Anyhow, let me try to finish it. So Transact 2 is again similarly from April 17 to February 29. I'll try to finish it in a minute. Transact 2 is showing the beach profile variations. Transact 3, again, how the variations is happening near to the berm and as well as how the slope is varying. Transact 7. So the oscillation between the the berm and the low water line, high water line, yes, it can be about 15 to 20 meters. That was the major variation we can able to see, including the slope. Yes, the non-monsoon season, we could able to see that flat beach it was able to witness, and as well as the slope, which shows that in range of 11 point, approximately less than 12, it should be called as a it's not a steep slope, which is not to be a high rate of erosion, which can be able to easily derived from these slope studies. Again, the studies and the identification of the berms, shorelines, and all this marked. Transact 1, 2, 3, and all, even the 2020 to 2021 separately marked, and it has given how the beach profiles is majorly very near to the berms, and because of this slopes variations, which Transact is provided in this one. As I said, yes, during the pre-monsoon time, we normally witness there is not much erosion, but in case of some kind of pleasure location, it seems a kind of erosion accretion. Being southwest monsoon, where now we are facing, even last month, 2 months before also we did a survey, we saw that some kind of erosion is started some locations. But everybody knows that the east coast during northeast monsoon erosion is inevitable, and also we recorded. Post monsoon, yes, again the erosion will start. This about the characteristics changes and comparison between the season variations between the 2017 to 18 of each profile Transacts. And finally, we just marked the HL and LTL. How much the variations is happening between the HL to HL is about 20 meters.
Sri Ganesh, can you please conclude?
Yeah, this is my final slide. Shoreline monitoring is required some kind of monthly monitoring, which is practically need to be carried out by the high accurate technologies. Even now, those satellite technologies come up. Yes, but still, the RTK GPS also satellite navigation based GPS is on that. So this can be also taken into the consideration for the shoreline monitoring for the erosion accretion. As well as based on this, you can be able to compute that rate, but still it is not a process. Yes, there are some rubble motors built at 40 to 50 meters that need to be again reviewed. Yes, this kind of technologies will definitely enhance our already available knowledges for the management of the sustainable management as well as the protection and the development in future also. Thank you.
Thank you, Dr. Sri Ganesh, for the very nice presentation. So I have a couple of questions which I'd like to mention. You had actually had a study on the seasonal and the annual shoreline changes, right? Do you have the data for a long time series for this particular region, or how long the data has been collected?
Yes, sir. We collected continuously for 35 months with a certain breaks. That is the only period of this field monitoring.
Almost about 3 years data you have.
Yes.
Okay. So you may not be able to find out the inter-annual variability as well as the intra-seasonal from this because it's a short time scale data. Okay, fine. Then you mentioned about the transects. What is the distance between each of these transect?
As I mentioned, it's about 100 to 150.
Okay, it's varying 100 to 150 meters. Fine. I think from your study, you can also have a look into how this wave characteristics. Of course, the wave characteristics again depends on the beach slope. You can finally, I think you can estimate the Ribaren number, and you can have a seasonal look into the variational of the seasonal, how the seasonal part is basically affecting this the coastal geomorphological changes. maybe that you can actually do it for your future part of your study. It looks interesting. But your presentation, I think you have just very highlighted that the erosion is basically happening during the month of March to August. This is the critical time when the erosion is happening in this area, right?
No, actually, during the time of the northeast monsoon. For the east
that
coast.
is a northeast monsoon, okay.
Yes, the period of October to till December, it will be very severe. But now from 2018-19 data shows that it is even showing little January, February also, it is showing some kind of erosion.
Maybe in the futuristic prediction, or you can say that because the wave activity is also changing in these areas, like in the Bay of Bengal as well as the Arabian Sea, maybe it will be an interesting study to look into the changes that is expected in the futuristic climate change scenarios and all. Thank you.
Definitely. Thank you
very much.
Thank you, Professor.
Thank you very much. So now let us go to the next. So before the next presentation, let us give a try to Praveen Kumarkar. I think he is waiting for some time. So Praveen, actually, can you please join?
Yes, sir. I have joined. Now I'm audible, sir.
Yes, you're audible. You're audible
okay,
now.
Okay. Thank you, sir.
Can you please load your presentation?
Yeah. I'm sharing, sir.
Yes, Praveen, you can start. Actually, you can just load your presentation and start.
Is it visible, sir?
Yes, it is visible. You can make it the full screen.
Okay, thank you, sir. Thank you for giving me such a chance.
Yeah.
Now, I am very much interested to present my slides. Anyway, this is my title, shoreline change near Gopalpur port and the erosion accretion pattern. So these are some of the outlines. Introduction, coastal structural information at Gopalpur port, objectives of the present study, followed by material methods and oceanographic conditions near study area, results discussions, followed by conclusion, and at last feedback session. So shoreline changes, actually shoreline change, already some candidates have told that this is the meeting part of the land and the shore. So it is naturally changes, the shape it is always changes because of some coastal structures, because of some cyclonic events. So we have carried out a survey along Gopalpur coast since 2012 to 2020, and the longshore sediment transport along Odisha coast is towards north always, which enables the littoral drift towards north. That is why in our Odisha coast always the sediment transport is from south to north around the year. As a result, because of the presence of the coastal structures, deposition is occurred to the south and erosion to the north. At Gopalpur port, several coastal structures it is going on. So in order to investigate the impact of these coastal structures on shoreline, this study is carried out since it may be mentioned that along Odisha coast is 1.10 to 1.29 cubic million per million cubic meter per year. So this is the study area. We have covered almost along 10 kilometers to the south and north of the port. So these are the transects. To the south of the port, there are 10 transects, and to the north of the port, 10 transects at an interval of 500 meters. Though the study is progressing since 2007, but I have presented from 2012 to 20, and some of the coastal structure informations are presented in the forthcoming slide. So these are the informations of coastal structure along Gopalpur port. You can have a look that during 2012, this is the length of coastal structures such as breakwater, intermediate breakwater, and all these drawings to the south and north. And in the subsequent period, because of the wave dynamicity and because of the cyclonic event and because of the port development activities, some of the coastal structure, length of the coastal structures has been enhanced, and some of the coastal structures are submerged. So my objective is to understand the impact of coastal structures on shoreline change and the geomorphological process from last 10 years about the coastal stretch of 10 kilometers, and to determine the vulnerable areas along this coast using the statistical features such as net shoreline movement, shoreline change envelope, endpoint rate, and linear regression rate. So this is the study area. This is the Gopalpur port. To the south of the port, there are some coastal structures are developed, and to the north of the port, a series of growing field is there. And from this region, a 15-kilometer far Rusikulia River is there. So my study region is covered at A station, which is to the south of the breakwater, and to the north of southern growing, the station is B, and inside the growing field there is station C, and beyond the growing field, station D is there. So some material methods are described. For beach profile measurement, we have used RTK GPS and total station. In order to find out this beach profile, Leica GeoFish, ArcViewGS, and Terra models have been used. After the processing, we have computed the beach volume and beach width with the help of BMap software. And this is the methodology for shoreline. We have used DGPS in order to find out the shoreline. And after the collection of data, we have used it in our laboratory, and it is used, the DSAS software is used in order to find out the statistics. So these are the basic oceanographic conditions near Gopalpur port. The mean spring, the tidal range near Gopalpur port ranges from 0.85 to 2.39, and wave height ranges from 0.25 to 0.97 during the observation period. The observation period is during 2008 to 9, and the wave period ranges from 7.2 to 10.8 seconds, and the wave height also ranges from 0.26 to 3.29 meter. So this is the result part. Actually, we have observed significant changes from 2012 to 2020 near both sides of the port. From in this 8 years, it is observed that the shoreline has progressed consistently because of the shore perpendicular structures. However, in the year 2013-14, a very severe cyclone storm Phylline has crossed along Odisha coast, which has a significant impact on the shoreline, which is reflected in the study. And after construction of southern breakwater, you can see this is the southern breakwater. So after construction of the southern breakwater, there is significant development of the shoreline till date. And at north of the Gopalpur port, the shoreline shows a decreasing trend here. However, to the beyond the growing field, after the we have suggested Gopalpur port to nourish the beach in order to arrest the erosion. So they have followed the beach nourishment, and following the beach nourishment, there is a progress of beach to the north of the growing field. So interannual variation indicates that the beach between 0.5 km to 2.5 km, which is north of the northern growing, is comparatively stable. So this is the statistics at Gopalpur port. Here also it indicates that as near to the south of the southern breakwater, near 2.5 km, the shoreline change envelope is maximum. On the other hand, shoreline change envelope is maximum at 3 km north of the northern growing. So results indicate that the shoreline oscillation is at its peak to the south of the southern breakwater and to the north of the northern growing field. And the net shoreline movement along this port north suggests that the length of present shoreline is less as compared to 2012. However, beyond the growing field series, it is positive because of the beach nourishment. And endpoint rate also indicated that to the north and to the south of the port, both the regions from 2.2 km to 3 km, the dynamic region is there. In this region to the south of the port, there is significant development. However, to the north of the port, there is significant erosion. And linear regression rate also indicates that at south of the port, LRR is positive to the south of the southern breakwater with maximum of 6.3 meter per year at 2.5 km. However, at north of the port, it is distinctly negative in between 1 to 2 km, and beyond growing field, it is positive. So beach morphology analysis, beach profile analysis indicates that the profile at south is very stable, and you can have a look at near the backshore region because the backshore is very silent. However, the disturbance is at foreshore and midshore, and since 2012 to 2020, the beach profile also indicates that there is significant development of the width of the beach. However, this is this southern growing region, near southern region. This is the profile for 2012, and there is a significant decrease in its beach width because of the longshore sediment transport. There should be deposition. However, Gopalpur port authorities have taken out the sediment, moved out the sediments in order to fill the beach to the north of the port. That is why some erosion is experienced. And at north of the port, you can see that there is a steep slope profile inside the growing field. However, because of the beach nourishment beyond the growing field, there is a stabilized beach experienced, and beach field activities by Gopalpur port help a stable environment beyond the growing field. So these are the outcomes from the beach profile using BMAP software. Here also it can be indicated that at Station A, which is near south of the southern equator, there is significantly development of shorelines. However, intermittent erosion and deposition is occurred at rest of the stations. And this is the sediment pattern. The sediment samples also characterize.
You have one more minute. You have one more minute.
I'm completing. Let me complete. So mean sediment indicates that overall the mean sorting spin and kurtosis of the sediments indicates that sediments are mostly medium, moderately well sorted, symmetrical, and mesocotic, and majority of the mesocotic followed by leptocotic exhibits the depositional environment at south of Gopalpur port. So this is the average statistics of the sediments from 2012 to 20. Here also, as mean size of the sediment increases, the sediments are found to be mesocotic, and because of the medium sand and fine sand presence, there is a stable environment near the study area. So these are some of the photos of coastal construction near Gopalpur south and north port. And before the construction of the coastal structures, there were erosion to the south of the port and to the north of the port. After construction, there is a healthy depositional beach observed near the port, both sides of the port. So this is my conclusion. So some points are the shoreline change, beach profile, erosion accretion is observed 10 km along this 10 km stretch, and it demonstrates that the impact of shore perpendicular structures along with the cyclone, which modified the shoreline change at both south and north side of the port. And results conclude that the major stretch of the shoreline on the south of the port is under accretion category, while 2 km shoreline on the north of the port inside the growing field, it is medium erosion. However, beyond the growing field, there is again accretion observed. So the geomorphology study further suggests that
can you please conclude?
Praveen Kumar Kar, it is a very interesting and a very detailed study on the erosion and the accretion pattern relevant to the considering the Gopalpur port. You have used the data from 2012 till present in your analysis, and you also mentioned about the total amount of sediment transport load actually varying from 1.1 to 1.29 of 10 power 6 cubic meter per year. It's okay, good. You also considered about the shoreline change statistics. You've done a very detailed study of that, and you're able to identify some of the oscillatory patterns that you're finding in the smaller stretch of the coastline. So as far as the Gopalpur port is concerned, it is fine, good. But my question is whether this is going to affect any other region in Odisha. For example, the Puri is facing a lot of erosion these days. I think you may be aware of it. The Puri coast, there is a lot of erosion happening and high wave activity coming in that region. So does this activity has any role on this Puri coast?
No, sir. Actually, we are doing observations since 2007 at Gopalpur, along with the Gopalpur tourist beach, and to the north of the Gopalpur port, there is Rusikula River. So we have, our study indicates that the port impact is up to 4.5 kilometers to the north of it. Beyond that region, there is no impact.
Okay. So basically, it means maximum it is the impact is up to 4.5 kilometers north.
Yes.
Okay. Fine. That is okay. So you have also done a sediment size characteristic analysis. So how did you do this part actually, sediment size?
Sir, we have used that RACE AS200 sheep seeker is there. After collection of the samples, we have washing it, and after oven dried, 100 grams of sample is taken care. After
doing the sieve analysis, basically.
Yes, analysis. Yes, yes.
Okay, fine. Thank you very much, Dr. Praveen Kumar. Very interesting presentation.
Thank you.
Thank you very much.
Thank you.
So now let us go to the next presentation by Suganya. The topic is on challenges in design of intake structures in the remote islands.
Yes, sir.
Yes, Suganya, you can make it in the full screen mode. Yeah. Yeah, it is fine. You can please start your presentation.
Suganya, you are in mute.
Suganya, you are muted actually. Can you please unmute?
Hello, am I audible, sir?
Yes, you're audible. You're audible.
Now it is visible, sir?
Please make it in the full screen.
Yes, sir.
Okay, fine.
Shall I start, sir?
Yeah, please go ahead.
Yes, sir. I'm S. Suganya, currently working as a project scientist in National Institute of Ocean Technology in Offshore Structures Department. Today, my topic is going to be the challenges which we are facing in design of intake structures in remote islands. My Offshore Structures Department is basically involved in the development of LTTD process islands in islands. As we all know, islands has deficit of fresh water because of it is surrounded with all sides with seawater and there is no groundwater resources also. So it is sufficient, it is deficit of fresh water. So what we have planned is to make a low temperature thermal desalination, which is nothing but it makes the available ocean gradient, thermal gradient, and we'll heat the warm water, and then we'll make the vapors to condense, and then we'll get fresh water through condenser. As we know, this is the thermal desalination process. Since island is having a steep bathymetry profile, we can get a cold water at around 500 meters of water depth. We can get 12 degrees Celsius of cold water. In warm surface, we can get around 25 degrees Celsius of cold water. So with these temperature differences, we'll collect the water into the flash chamber where it will get pressurized, then it will be condensed in condenser and fresh water has been collected. This is what the basically LTTD is. For making this process, we are basically using three main structures, civil structures, which is nothing but a sump, a plant building, and a trestle. Sump is nothing but an intake structure which collects and stores warm waters and cold waters. Plant building is nothing but a structure which holds the process components like flash chamber and condenser, where the entire process will take on. Then the trestle is used to carry the pipelines from sump to the plant building. Now my main area of interest is this intake structure. What are the difficulties we are facing in this intake structure? This is the basic layout of an intake structure in LTTD plant, which has a cold water component and a warm water component. This cold water compartment will have the water from the 500 meters water depth using a deployed cold water pipeline. Then we'll have a warm water component which will collect the water from the surface. Additional extra wing portion is available to ensure the stability against the highly lateral force. Then it will consist of a screen walls to remove any bulk impurities are there. So this is the basic layout of the intake structure. So what is the design difficulties we are facing in case of this in islands? What with extra difficulties which we are facing is the first one is soil condition. When we are using a normal construction, normal intake structure construction, there will be a flat ground, so no issue of that much soil condition. When we come towards the islands, it will have a coral reefs which will have more undulations, soft rocky base. We have to most trenches will be available. We have to make it straight up. We have to level it. For that, we need a highly equipped divers and all. So this which will make the installation part very tedious. Then next one is the breaking wave force. So for a structure which is used to design in a nearshore environment, that is a breaker zone environment, the high amount of breaking wave will come and incident onto the structure, which will be the highest lateral load, which will lead to the stability issues like overturning and sliding. Then the minimum wall height. In case of normal structures, we can go for only up to the available capacity and extra freeboard, which is enough. While in case of our island desalination things, we have to consider the storm surge, highest tide level, then extra air gap, available significant wave height, etc. So as I already said, the overturning and stability issues also has to be taken care of, and then the installation difficulties. Unlike a normal construction, we have to go for using a barge, some underwater construction, underwater concreting has to be done. So extra additional things has to be is required in case of this island construction things. So as I explained in this slide, the major component is nothing but the breaking wave force, which will lead to the stability issues. This breaking wave force is calculated on the vertical front structure using Godas's method. This is based on the series of laboratory data and the theoretical concentration considered by Goda. What he used is he used the basic components like a depth of water, what is the significant wave height, what is the depth of water at a distance of 5 times the significant wave height. With all these data, he has calculated and giving the wave load in terms of wave pressure distribution, which is nothing but in a straight wall, we'll apply the load with the pressures. So P1 is the load at the still water level, and P3 will be the load at the down, and P2 will be the load at top, and extra uplift force will be there. So this will depends upon the shape of the structure which we are considering. So Goda has continued his research, and he is saying that based for different shape, different wave loads can be estimated. For example, upright walls he is using, and he is estimating using one method. Then for sloped walls, then upright wall with rubble mount protections, then upright wall plus upright plus sloped wall combination, then walls with it. These are the some of modified Goda's method he has been arrived at. Based on this, in this paper, I have considered two configurations, which is nothing but an upright sump and a sloped sump. Upright sump will have total of 9 meters height, whereas the sloped sump, I will stop the height up to 6.5. Then I am making it into a sloped structure. Then I am examining like what the impact of wave force which is coming onto the structure. So what are the loads which I have considered in for the design of the structure is first one is dead loads. These structures are mainly made of RCC components, that is reinforced concrete. So weight due to their self weight, and the water pressure is nothing but the main component, that cold water component and warm water component will have water pressures, and hydrostatic pressure is nothing but since it is installed in 5-meter water depth, the surrounding water pressure. Then the wave force is estimated using Goda's, and extra ballasting portions will be there for additional stability. So extra ballasting loads. So these loads were installed in model, and then load combinations were given like how the in-place stability has to be considered without ballasting, with ballasting, without water, and with water facilities. So the main load combination is limit state of collapse and serviceability. It's a basic like from collapse, we'll take a shear force and bending moment diagram. Then we will estimate what is the reinforcement has to be taken care of. And then in serviceability, we will be able to estimate the crack width, which is very important for the water resistant structures. So main thing which will play an important role is because of this high lateral load, what is the step, how we are making it stable against sliding and overturning. So this is the numerical result which I have got from for sloped and upright sump. So basically the weight, its buoyancy, its uplift due to wave, horizontal downward wave components, resisting force, everything has to be taken care of, and the additional force which is required to stabilize the sump in case of sloped configuration is around 200 tons, and in case of upright is around 280 tons. From this, it is clear that in-place stability can be assured with will be assured in a good manner when we are using a sloped configuration. Then we are going for flotation stability. Why flotation stability is coming into this point is our sump has to be installed in 5-meter water depth, where the wave force will be very high at the location. So what they are doing is sump has been partially constructed on the lagoon side where the water depth is less and the wave force will also be less. Then it will be towed along the moat, and then they are placing it in the required place. Then using ballasting, it has to be placed in the position. So while flotation, we have no right meta center, and the available drag will play a major role in determining the determining the sump configuration. So as I said, this is the construction methodology. This is the casting on shore. This is the launching into the lagoon. Then they are towing it from like this into your through your mouth. Then they will take into your offshore component. Then they will place it in a 5-meter water depth. This is the picture of a towing of a kite zone. So what is metacentric height? How it is measured? So basically, for a flotation body, metacentric height should be positive. What I have done is I have taken a series of width of from starting from 8.5 meters to 10 meters. So for every 0.5 meters, with the available metacentric height, how much is the lift of the sump that has to be constructed on the shore before towing? This is our study. So it has been observed that for a 9-meter width sump, we'll get a metacentric height of around 1.1 if we are using a lift of 6 meters. Same way, the available draft is around 3 meters in island mouth. So for the available for different various draft conditions also, various flotation methodologies has been done, and we have arrived at like a 9-meter width of the sun with a 6-meter lift. It is safe in flotation.
So what? You have one more minute.
Yes, ma'am. Yes. So wave loads is basically inclined sump. Will in wave load can be categorized into lateral force and a downward force. The downward force will give extra stability, which will give more stability against loading. So for the every 0.2 meter increase in tidal range, what is the stabilization weight has been depicted in this graph. Then this is the by this only we have arrived at the configuration of Kalpanism, where we are getting around 1.9 meter of metacentric height. Then this is nothing but a response amplitude spectrum, which has been constructed, which has been analyzed using a model where pitch, heave, and roll has been monitored. As from the graph, we can see that a roll is predominated 90-degree waves and pitch is predominated 0-degree wave. Here, basically, they will make a model and they will give wave loads for 0, for 45-degree and 90-degree. Nowhere it is matching with our natural wave period. So the structure is seen to be safe against flotation. So as I said, against stability, lateral stability, that additional stabilization is made by using rock anchors. Rock anchors are nothing but a small pile-like structure which is attached to the base of the sump. So this is nothing but the pull-out capacity has been estimated, and how much the depth of the embedment has to be gone inside the soft track so that it is stable against lateral finger. So this is some of the pictures of this Kalpeni sump. So this is our Kalpeni plant, which has been successfully completed its construction and installed in January 2020. And this is some of the pictures of installation. Thank you.
Yeah, it was a very interesting presentation, and you have done a very detailed analysis actually on the challenges in the design of intake structures.
Yes, yes.
Have you actually done any geotechnical study on the soil conditions?
Yes, sir. Geotechnical study has been constructed by geotechnical engineers. They only have designed this rock anchor things based on the soft rock base.
Okay, fine. And to address this overturning, because overturning is also one of the important aspects in the structure.
Yes, yes.
So how did you take care of it? Have you used any standard protocol which is given by Bouchard?
No, sir. We have stabilized it using additional ballasting chambers, which will have additional
ballasting chambers for
ballasting
right.
chambers.
Okay. And I think one of the issues that you're mentioning in your presentation is about breaking waves.
Yes, sir. Yes, sir.
There has been a lot of studies which have been carried out. I think you're aware of the PINC report.
PINC guidelines, yes.
PINC report. They have actually suggested that you can increase the number of berms. The number of berms actually can be increased, but of course it works very good actually when the water level variation is very high in an area. Or for example, I'm talking about the tidal variations. If the tidal water level variations are quite high, then increasing the berm actually is found to be a good engineering design for this type of structures.
Yes, sir. Yes.
And one more important thing which I would like to, maybe you can look into it, because the shape is very important. The shape actually. So why don't you think about a shape which is curved on the freeboard?
Yes, sir. Okay.
Because it has been done in Japan. It has been done in Japan and it is successfully working.
Okay, sir.
And I think nowhere in India they have done this curve shape design for the freeboard.
Okay.
So you can look into it. It will be very interesting. Yeah. Thank you very much.
Thank you. Thank you.
Thank you very much.
Thank you.
So now let us go to the last presentation of the session. That is by Sondi Sudhir. the topic is on monopile supported trestles for intake and outfall systems of at remote islands. Sondhi Sudhir.
Hello, sir. Good afternoon, sir.
Good afternoon.
Am I audible, sir?
Yes, you're audible. You can make it in the full screen. Yeah.
Yes, sir. I'm doing it.
Yeah, please.
Good afternoon, everyone. My name is Sudhir. I'm working as process scientist at NIOT. Today, my presentation title is Monopole Supported Trestles for Intake and Outfall Systems at Remote Islands. So the main goal of this presentation is to understand and know the monopile foundation advantages in remote islands. Let's get into the PPT. These are my contents I'm covering in this presentation. Introduction. First, I will give the overview of infall and outfall structures, and then research significance, and followed by objectives, methodology, and results and conclusion. Sir, infall and outfall structures are generally associated with the approach trestle, which is used to collect the water for various industrial purposes. So the foundation for these trestles will play an important role in terms of stability, because it has to withstand the support of the entire weight, self weight of that bridge, and also withstand the lateral loads due to high breaking waves in the currents. And also it will also influence the time for the construction. Normally for these trestles, normally 2-row piles are utilized for the construction due to the easy construction methodology. But the single row piles can also be designed for the trestles, sir, but this is not generally opted in the construction industry because of the eccentric loading of the gantry and movement of the steel gantry during the installation time. So this is my point of interest to study the uncertainties of the 1-row pile during the installation in order to reduce the project completion time and the economy of the project. So before going into the research significance, I would like to give an overview of the installation method used. Here for this installation method, I have used the end-on piling method. In this, here you can see the picture. Here the temporary movable gantry, which consists of the 2 main longitudinal girders. You can see the side view of the longitudinal gantry. You can only see the one girder out of 2. And also the remaining equipment like A-frame, winch machine, boilers, all are placed on the steel gantry for the installation purpose. And this is the A-frame. And this is the significance as I show the A-frame on the steel gantry. This plays an important role. So this A-frame is used for the boring of the piles, but the placement location of this A-frame will place an important role in influencing the forces and bending on profile and pile cap and pile. To put it more simple, if you look at this picture, this is the elevation of the steel gantry. This is the A-frame, and this is the plan view. This location, if we place this A-frame exactly at the center of this steel gantry, the load coming from this steel, this A-frame will equally distributed to the 2 main girders and to the piles. And this is a normal scenario which is practiced at the site. But my question is, if we place this A-frame at this edge or at this edge, what is it? What is the behavior of that? Like how the load will transfer to the main girders. If we place this A-frame at edge of this steel gantry, the load from the A-frame is unequally distributed to the 2 main longitudinal girders. In case of the 1-row pile, it will create the more instability in the 1-row piles. This due to the eccentricity loading. So my study is to carry out this instability due to the eccentricity in loading has to be taken care in the design of 1-row pile. These are my objectives, sir, to analyze both constructional and operational loads that come onto the structure. And also my objective is to evaluate the structural performance between the 1-row and 2-row piles, and also to compare the cost of the construction between 1-row pile and 2-row pile. And this is a methodology I have followed. I have to study these objectives. I have divided into 2 sections. One is pre-installation and post-installation. Pre-installation in the sense during the installation time. So during the installation time, I have considered 2 loading scenarios for each type of file, 1-row pile and 2-row pile. As I told you earlier, equal loading means A-frame is placed exactly at the center of the steel gantry. And unequal loading means A-frame placed at one edge of the steel gantry. I would like to see the structural behavior of these type of foundation by considering these equal and unequal loading. And also in the post installation, I have considered the constructional operational loads, and I designed in StatPro and compared the reinforcement and did the cost analysis. To study these models, I have considered the ongoing marine bridge for the LTTD plant in Lakshadweep Island, where NIOT is doing the Prestige 6 Island project for LTTD plants. And these all models are designed in the StatPro software. This is the structural configuration of the steel gantry and permanent pile and temporary piles. And this is a permanent pile of diameter 800 mm. I have designed in the StatPro. These models are from the StatPro only. And this is the longitudinal beam of the steel gantry. This is a temporary movable gantry. This is the structural configuration of entire thing. You can see the sectional properties of the bracings and temporary pile cap, permanent pile cap and all. Coming to the loads considered during the installation. What are the loads coming onto the steel gantry and piles? I have tabulated here based on the design. I have calculated based on the design code standards. During the installation, I'm talking about the installation stage. So here the dead weight will come, like dead weight will from the equipment used for the installation of the piles, like A-frame, winch mission, bilets, everything I have considered as per IS 875 part 1. And the live load, wind load, and wave load also have calculated as per AICA standards on the piles. Have applied at the depth of water level as a point load. And this is, if you look at this picture, this is the place where I'm talking about, like this equal loading and unequal loading come into the picture. This is the location of the A-frame. Have calculated manually that equal and unequal loading applied as point load on the steel gantry, main longitudinal bars. These loads are only in during the installation stage. Post installation, once the pile is installed, the steel gantry is moved forward followed by placing the pile cap and the deck slab and all. The loads from these pile cap and bridge deck pedestals double T-beam are calculated and have applied on the pile cap as a point load, and the wave load also. These are the loads. Coming to the analysis and results, during the installation stage, I have considered the temporary load combination as per IS 4651 part 4. Here, if you see the load path will be the whatever load coming to the steel gantry will transfer to the pile through the wheels. So the weld connections of the wheels has to be checked. So I have calculated the weld strength, design shear strength as per IS 800 manually, that is 577.6 kilonewton. And I have to compare this with the forces coming onto this wheel location. Wheel locations are like 1, 2, 3, 4. There are total 4 wheel locations are there. I have considered the wheel forces coming at that wheel locations. I have tabulated here. Like based on this results, I can figure it out that in 2-row pile, the weld connections are failing during the unequal load distribution, because the loads coming onto this 2-row pile is very double when compared to the 1-row pile. And also I have cross-checked the bracings. These bracings are the connections between the permanent and the temporary piles used to transfer the horizontal forces. And I have designed it as a truss member. It will carry only axial forces. I have taken the results from the StatPro, like maximum axial forces in the bracings. From this, in this figure, you can see that in 2-row pile, for both the equal and unequal loading, the bracings are failing here. See, if I increase the structural configuration of that bracings, it is passing. This is because the wave force coming onto these piles separately will increase the maximum axial forces in the bracings. This is one of the results. And in coming to the post installation, I have analyzed for the survival load and normal load combinations as per the IS 465. I have considered the maximum bending moment and the reinforcement required for these foundations, and I have compared. So this is the maximum bending moment in the 1-row pile, and this one is the maximum bending moment in the 2-row piles, and the reinforcement requirement as per the StatPro, and also number of piles. For example, from this table, for example, if we for the bridge requires 10 piles means in 1-row pile, in the 2-row pile it requires 20 piles. The construction of the 20 piles is more difficult and it would consume the more time and the economy also compared with the 1-row pile. So based on that above work, I have concluded these points. Like the lateral force coming in the single row pile is very reduced significantly compared to the two row piles. And also, as I said earlier, the bracing is also failing in the two row pile. If we increase the that bracing to the higher structural configuration, it is passing, but higher structural configuration will increase the cost of the construction. And also it is clearly seen that the construction time for the single row pile will more effective, like it requires less time compared with the one row pile. So if in the remote islands, like where the high probability of high wave breaking zones areas, if we opt for the two row piles, it requires the more time for the construction, or it will also requires the more material. So it is very difficult to transfer the material from the mainland to the island. It involves in the more cost and the economy. So the one row pile is also economical as it requires the less material for the construction. This brings us to the end of my presentation, sir. Thank you.
Thank you very much, Dr. Sudhir. It was a very nice presentation.
No, sir, Sudhir only. It's not. I'm not a doctorate.
Okay. So thank you very much. It was a very interesting presentation, and you have done a very detailed analysis to find out the load combinations for this monocoil supported trestles. Your study basically also looked into the uncertainty which are associated with the different types of loading conditions and the end-on piling methods, which you have highlighted very well. One of the important things that you have highlighted in your presentation was on the placement location of the A-frame on the steel gantry. I think that's a very important factor that has to be taken into consideration.
Yes.
And for the operational loads as well as on the stability aspects.
Yes.
But in one slide, I was looking into the different loads that you have considered, like the dead load, the live load, wind and wave loads, right?
Yes, sir. Yes.
So I think you should consider also the currents also, because your the structure is basically in an area where the wave breaking is quite high, right?
Yes, sir.
So also the current loads also can be taken into consideration in your calculation.
Yeah, okay, sir.
And one more thing, and if you look into the PINC reports, there are the formulas have been given for the serviceability factors under different load combinations.
Yes, sir, but I can
You can work on it actually. So
yeah,
then you
okay,
can come out with an optimum design under all conditions.
Yeah, okay, sir. Sure, sir.
Yeah. So thank you very much, Sudhir. It was a very interesting presentation. Yeah.
Thank you, sir.
Thank you. So Josie, I think we are done with all presentations, no? Yeah.
Yes, sir. Yes, sir. Actually, we had all the 11 presentations were carried out, and mostly they stick to the timing also. We are extending only 15 minutes, delayed by 15 minutes only.
Yeah.
So I thank our chairman, Professor Prasad Bhaskaran, for chairing, and moreover, like for making it very interactive and very lively. Thank you, sir.
Thank you.
And I also thank all the participants for excellent presentations and for sticking to the timing. Thank you, Rohit. Thank you all.
I would like to thank Professor Prasad K. Bhaskaran for chairing the session and nicely conducting the session, and Dr. Josiah Joseph to help me to coordinate the session. Thank you all. We can join the next session on Ocean Engineering and Technology after the lunch, 14 o'clock.
Thank you very much.
Thank you. Thank you. Now we can go to offline.
Yeah.
Thank you.
Thank you. Thank you all.
Request you to please start the session. We are live now.
Am I audible? Venkatesan here.
Good afternoon, sir.
Good afternoon, Dr. Prasad. I was waiting. I was in the lobby for some time.
Yeah, it was. I think they took a little longer. Dr.
So
Saurabh
what's the
also is
plan
here.
now? I listen to you now.
What we can do is we'll start with your introduction,
Okay.
and Dr. Saurabh will introduce you, and
Okay.
then after that we have 5 presentations.
Okay.
And that begins with Miss Monica Malila. She's already there inside in the
Okay.
room. So maybe once Saurav gives introduction to you,
Yeah.
people also will know about you, and then especially the people who are listening from outside.
Yeah.
And then maybe you can take a charge of session and then invite speakers one by one.
I wish you also take part in that.
Sure.
What I feel, it is better you have taken initiative. You are also senior. You introduce the speaker.
Fine.
So moment he introduces, I will welcome all of them.
Yeah.
You introduce, but I will conduct the session asking question. That part I'll take care.
Yeah, sure.
Introduction, you take care.
That's right.
So we 3. Is it okay, Dr. Saurav? I'm audible to you? I think he's muted.
Saurav, you are muted. You have to unmute.
Then as we discussed, maybe
Mr. Venkatesan.
Yes.
You can hear me?
As per agenda,
Yes.
you are the chairman of this session. So I will make you co-host. So you can join and unjoin and stop video, whatever you want to do that time.
Okay.
And I will play a 15-minute timer.
Yeah.
So you have to tell everyone to that.
Fine. The timer will be seen to me. Seen to the speaker also?
No, you'll see later. Once they start session, I will.
So I need to prompt them at 3 minutes before, or what's the practice?
Pardon?
Should I need to prompt the speaker 3 minutes left prior to that?
No, speaker also show the time.
Fine. So I don't need to say anything, just 15 minutes. I should control the time, correct?
Once they over the limit, you have to tell them.
Fine. I will take moment to introduce, I will take control, and Dr. Prasad will introduce the presenter. Then I will take care of the conducting the session. Not an issue at all.
Yes, sir.
So first to Dr. Saura, I am Venkatesan, working in NAOT. I think you are in NAO. Which?
Yes, sir.
Yeah. Which department?
Yeah, my name is Dr. Saurabh Mandal. I am from Ocean Engineering Department.
Ocean Engineering.
Yes. CSRNI.
There was one Mandal, Dr. Mandal, you are aware?
Yes.
Yeah, unfortunately,
yes,
no more, and he was my good friend. I was there for 15 years.
Good to know, sir.
Yeah, I was there until 97.
Yeah, I was just seeing your introduction and this write up. Then I came to know you are in.
Yeah, very good, nice. And Dr. Prasad is our senior scientist who worked on energy and fresh water. So he is expert and authority in that field here. So very good. We 3 of us will conduct. Okay, we can start now.
Saurav, please, you start with the introduction of speaker. So not speaker, chairman.
Okay, so okay, when you just start refer that thing. So should I start?
Yeah, you start.
Okay. The innovation in the field of ocean engineering and technology can help ocean navigation, ocean studies, and environmental safety. Welcome you all to the technical session 18, Ocean Engineering Technology of the 7th National Conference of the Ocean Society of India, Osicon 21. May I introduce Dr. R. Venkatesan as the chairman of the technical session 18, Ocean Engineering and Technology.
Dr. R. Venkatesan earned his PhD degree from IISc Bangalore and continued his academic pursuit to complete courses in marine environmental pollution and management and international business management from IIFT New Delhi. He began as a scientist at National Institute of Oceanography, Goa, and rose to highest position as Program Director for Ocean Observation System at NIOT. Dr. R. Venkatesan has 35 years of experience in the field of ocean science and technology. Recently, he is recognized by the World Meteorological Organization and UNESCO IOC for his outstanding services in global ocean data collection. He also received prestigious FTS Lockheed Martin Award, and as a chair of NTS India section, he received Outstanding Section Award. He led his team to Arctic to successfully install India's first ever Arctic Moot Observatory and received National Geoscience Award from the Honorable President of India. He has successfully established Tsunami Buoy network for tsunami early warning system in Indian waters. He was elected to prestigious position in steering committee member for GOES of UNESCO, IOC Paris, and DOES and Ocean Science. He is member of Joint Task Force of Smart Cables by UN Organization, ITU Geneva, WMO, and UNESCO, IOC. He worked as regional coordinator for South Asia and was posted in Colombo under United Nations Environmental Program, UNEP. Chair of ITP Data Buoy Corporation Panel, UNESCO IOC, and WMO Chairman, MTS Material Committee, and at national level chairman for the Indian section of IEEE OAS and MTS. IEI Kanchipuram, Vice President of NACU South India section, member of the Committee of SME by Confederation of Indian Industry, member of Defense Manufacturing Committee of Osicon, as a chair of the Committee on International Guidelines for Oceanography Instruments by DBCP under WMO and IOC. Dr. Venkatesan is a recipient of 11 distinguished awards at the national and international level. He started Marine Technology Society in India and 4 student chapters in college, and 5 students received scholarship awards. Besides several competitions like student AUP competition, etc., he has to his credit 100 papers in journals and 135 papers in conference, seminars, delivered more than 250 talks in conference, and also co-authored 2 books and filed 6 patents, editorial board member of 2 international journals. So now I hand over the stage to Dr. R. Venkatesan, sir. Sir, please continue.
Thank you, Dr. Saurav. Thanks for taking patience and reading it. And thanks to all the presenters today. Really, we are proud to be part of the Osicon conference. And I was also the executive committee member during the last period. And I'm seeing the great success in the last 3 years. Very good papers and very good interaction is happening here. And part of the last component of the whole conference. And I request Dr. Prasad to introduce the first presenter, and please stick on to the timing allotted to you. And also I wish other students to have questions ready so that we have a very fruitful interactive session during the next 5 presentation. Thank you. Let us start the presentations now. Dr. Prasad, please. Dr. Prasad? I think
maybe connection issue.
He was in office only. Just wait for a minute. Who is the first speaker? Can you uplink the slide?
First speaker is as scheduled, Monica Malila.
Can you uplink your presentation?
Monica.
Yes, sir.
Can you uplink your presentation?
Yes, sir.
Good afternoon, sir. Can I start the presentation, sir?
Just wait for a minute, Ms. Monica. Dr. Prasad is supposed to introduce.
Yes.
I will not start until just to put off the clock. Dr. Saurav, our time is not started.
I think
Automatic.
Dr. Prasad probably leaving there.
Okay, we will start. I think the clock is running now. We have Ms. Monica Malala and a project scientist from NIOT. I think she's going to give a presentation on performance of monopile platforms during service life. This is very important because I still know the work what they have done. You can see the picture. Erecting a platform of this kind in the ocean where there is a strong current and tidal variation is really a great challenge. It's sometimes we will see the laboratory simulation, but in the field condition, how it is installed, I think I'm sure that her presentation from the design to the execution will be very useful to all the listeners here, particularly students. With this, I request Ms. Monica to make her presentation. Please, floor is open to you.
Sir, thank you, sir. Good afternoon, everybody. As sir said earlier, the topic is performance of monopile platforms during service life. And the monopile platforms, basically it is used for wind data collection of offshore wind. On the monopile platform, a LiDAR will be housed, and the LiDAR will collect the wind data. Like it will be useful as a bankable wind data. So for a period of 2 years, it is important to get the wind profiles. It will be useful like a pre-feasibility study before the installation of offshore wind farms, which includes capital investment, huge investment of capital. That's why the topic has been adopted. And the basic objectives of the present study is to assess the serviceability of the monopile, because the monopile will have a serviceability limit since it will be housing a LiDAR upon that. The monopile should have a rotation of below 0.2 degree in order for the LiDAR to be serviceable. And then apart from the gravity loadings and environmental loadings, which will be in the offshore environment, we have conducted a study to get the response of the structure due to the phenomena like marine growth, scour, and corrosion. These phenomena are time dependent. And then the why the particular study has been adopted is, since the codal provisions and all are available for offshore platforms for a design life of 25 years, like offshore oil rig platforms, but the monopile, it has a short service life because it acts like a temporary structure. It has a short service life of 5 years. So the codal provisions will be overestimating the loads acting upon it. So for a shorter service life, we are going to study these 3 phenomena. And actually, the design life is only for 2 years, because continuous data for 2 years will be enough for the bankable wind data. But the study has been conducted for a period of 5 years. And the structure adopted is a monopile of 2.2 meter dia, which is embedded to a depth of 16 meters. And the soil profile is sandy soil. Then the environmental data near the at the particular location is wave height is 3.8 meters, and the current velocity is 1.8, and the basic wind speed adopted is 50 meters per second. And the tidal variation, since it is at the coast of Gujarat, the tidal range is high. It is about 8 meters. And then the loads, the platform which houses the LiDAR, it has been designed in StatPro. And then the support structure, it's done in SACS, which pertains to the design and analysis of offshore structures. And these are the loads adopted for the analysis. This basically includes gravity and environmental loads, which are dead loads, live loads, wind loads, and hydrodynamic loads. And the load combination is adopted as per API standards, and it is in working stress method. Here, the particular analysis is static analysis with pile soil interaction. Here, basically, the piles are modeled as non-linear springs. The soil is modeled as non-linear springs, and the code adopted is API RP2A, which is used for fixed offshore platforms. And then for different phenomena, we have studied the lateral deflections and rotations, and serviceability check has also been conducted. And we can see the marine growth is impacting much compared to the corrosion and scour. And in detail, when we go into the details of the parameters considered, first thing is gravity loads, which includes the weight and buoyancy factors. And then the environmental loads basically includes current and wind and wave. And apart from that, marine growth, scour, corrosion has been considered. Basically, the marine growth is accumulation of weeds or some marine organisms around the pile, which will increase the pile thickness. Not along with pile thickness, the marine growth also increases the roughness of the structure. So based on the pile thickness and roughness, the wave loads will also get increased. Because of the wave loads, the lateral deflections will also increase. And the marine growth, like along the depth, it will be varying. Here, the 10 meter below the seawater level, it's predominant actually. Then the pattern of marine growth, it's like at the near the Indian offshore platforms, the thickness of marine growth will be around 38 mm. But with age, it will increase. It will reach to a maximum of 68 mm at the time of at an age of 35 months. So the profile here, the graph can be seen, which will show the marine growth pattern for up to a age of 5 years. And then depending on the accumulation of marine growth, the surface coverage also will be changed along with the time. So based on that surface coverage, the drag coefficient will also be changing. Surface coverage and roughness factor increases the drag coefficient, and then the lift coefficient will be decreased. Because of the because of the increase in drag coefficient, the wave loads will also be increased. The graphs, first graph shows you the shows us the pattern of marine growth over the years, and then the surface coverage of the marine growth, and then how the drag coefficient will be impacted due to the surface coverage and roughness coefficient. And then coming to the next parameter considered, scour. It is actually the removal of foundation soil near around the structure due to the action of currents and wave. So the top layers will be removed. Because of that, because of the reduction in top layers, the axial and the lateral confinement will be decreased. And then because of the decrease in axial and lateral confinement, the deflections will also be reduced. And API recommendations have been used for this calculation of scour. And it particularly happens with sandy soil. And the final scour depth is taken according to the codal provision. The final scour depth has been taken as 1.5 times the diameter of the pile. And the graph shows the variation of scour with time. Actually, the scour is predominant in the first few months itself. The scour will be developed fully. Like 63% of the scour will be developed within a time span of 2 weeks. And then within a time span of 6 months, scour will be completely developed. So over the design life, the scour will be constant. And the first 1.5 meter to a depth of 1.5 meter dia of the pile, the soil will be removed. Because of that, the overburden pressure will be reduced, and so the overburden pressure will be corrected up to a depth of 6 times the diameter. Till a depth of 6 times the diameter of the pile, the scour will be filled. And then coming to the part of corrosion, it is a natural process in which the the decrease in the pile thickness, deterioration of the pile thickness will happen. Because of this, there will be a reduction in the stiffness of the structure. So in the design of the structure, we have used, based on some codal provisions, we have given some corrosion elements, and there are many other methods for the protection of the structures against the corrosion, like giving cathodic protection, sacrificial thickness, and protective coating. Here we have used an allowance of corrosion, like as per the DNVGL standards, the corrosion allowance of 0.4 mm per year on the external surface and 0.2 mm per year on the internal surface has been used, and with time it will increase, as can be seen in the graph. It is a linear phenomena. With age it will increase, and then these are the parameters considered, and then the performance of the pile for the particular phenomena, like for marine growth, scour, and corrosion, they have been studied separately, and the combined phenomena has also been studied. As we can see in the graph, two parameters we have studied basically, like first is the utilization ratio and second one is the rotation. Utilization ratio, actually it is the actual stress divided by the allowable stress, which should be less than 1, so that actually it should be maintained around some 0.8%. That means 80% of the material should be utilized during the life of the structure. From the graph we can see marine growth gives the maximum impact on the performance of the pile. The utilization ratio, like 40 at the end of the design life, there is an increase of 14% in the utilization ratio due to the impact of marine growth. And second comes the corrosion. It will impact up to 8%, and the corrosion, it is like a constant phenomena over the design life of the structure. And then due to the combined action of all these parameters, there is an increase of 25% in the utilization ratio of the structure. So and then the performance, the second parameter studied in the performance category is the rotation. As I said earlier, the rotation should be less than, like, it is a serviceability criteria for the LIDAR platform we have installed. So and from the graph again, like for the rotation, the maximum impact gives like marine growth increases the rotation by 12%, and then the second factor which is impacting the performance is corrosion. It is 8%, and the scour has minimum impact of 2%. And overall, the combined action of all these parameters, there will be an increase of rotation by 25%. So coming to the conclusion part, we have studied the different parameters over the design life of 5 years, and we can see that these parameters are impacting the serviceability criteria. So in order to come out with an economical structure, these phenomena are important in considering, as these are time variant, and the codal provisions or the assumptions given in the codal provisions will be up to a design life of 25 years. So for the temporary structures with a short service life, the time dependent phenomena are very important in designing the in arriving at the economical design. And these are the references I have gone through while doing this study. And thank you for listening.
Thank you, Ms. Monica. I think you covered it well before the prescribed time. I think it was a very useful presentation. Particularly, you will not find such presentation in a practical application oriented. Most of such work are linked to the modeling as well as theoretical lab studies. And I request Dr. Prasad, should we go for questions now?
We can, but we have not received any question here as well as on YouTube. So if we have any question, we can ask.
I have, because I really appreciate the whole work what she has done. how do you quantify the load per se because of biofouling? I know, yes, you have taken the surface roughness phenomena and that too related to vortex loading, what you will see. But the whole overall load of a structure, what one has visualized without fouling, with fouling, you talk about 68 mm in 35 months. How do you quantify that as a load? Because in service life, this is what is a concern now when you talk about life, extension of life for offshore structures in North Sea. After 30 years, when now you're talking about 25 years, they're all 30 years. This biofouling load is a major issue because one important thing, the load biofoulants start falling off. It doesn't remain for too much thickness. 68, what you mentioned is correct. How do you take that into account?
Sir, actually, I have taken a reference from the how the pattern will be on the Indian offshore platforms. Based on that, I have studied how the based on the thickness, I have read at how the surface coverage will be varying, and based on the surface coverage, we have to estimate the CDCM values. Basically, this CDCM only will be varying depending on the this roughness, because based on the type of marine growth, the marine growth will be different at different locations. So based on the type of marine growth, it will be classified as whether it is smooth or rough. And when it is covered by the rough coverage of marine growth, the CD will be varying depending on the roughness coefficient. So this variation, so this variation I have.
No, you have done well. Only my question is, for example, you have 10-10 you have visualized because of fouling becomes 11 ton or 10.5 tons.
Yes, sir.
Now that is again leading to cyclic loading. Now any incremental value leading to cyclic loading and fatigue loading, how do you address that? Presently, fine. Spoke about roughness, spoke about speculated vortex, fine. But what about the load increase? Because you have the factor what you use in that. Yes. In the end, biofouling factor is used for all your loading conditions. Yes. It's a very small phenomena only because they're all designed for temperate countries like North Sea where there's not much of fouling. When it comes to tropical like us, it's much more complex.
Yes, sir. You're asking regarding the estimation of loads, how yes. I have considered this. Yes, sir. Basically, I have designed it based on the Morrison equation.
Morrison equation. Yeah, that has got a factor of Morrison equation and a factor of fouling also. Yes.
Yes, sir. So in that, the factor I have made modifications for the particular factor, like the CD and CDM. I have modified it according to the study I have considered, and then the wave loads has been estimated.
That's what. This is what is important. Very good. Good work. I appreciate. Any other questions if anybody has got, or Dr. Prasad?
We have one question asked by Dr. Jena. He appreciated Monica's presentation, and he has asked that for performance of monopile, what precautions are considered for corrosion and erosion due to high suspended sediment and current? Partly she has spoken about it, but maybe briefly she can answer that.
Very good.
Yeah.
Yes, sir. Actually, I have taken corrosion allowance as per the standard, sir, DNV shield standard. So while designing I have designed for a thickness, I have given an allowance of around 3 mm. If for suppose for a design life of 5 years, I have considered an allowance of 3 mm. So at the site condition, it will be like around the 35 mm thickness of the pile. At the site, it will be 35 mm. But while designing, I'll be designing it for a thickness of only 32 mm. So
is there any standard that you're following for this?
Yes,
to decide
sir,
this. Yeah. Fine.
Yes, sir. There are DNV shield. Some class is there in DNV shield.
That's fine.
Code, sir. So based on that code, I have taken an estimation.
So recommended allowance you have incorporated.
Yes, sir.
Very good. I think that's it about it about the questions. Dr. Venkatesan, shall we move on?
Thank you very much, and we'll move on to next figure. Thank you.
Thank you.
Thank you, Monica.
You should publish in journal.
Sure, sir. Sure. Thank you, sir.
Thank you.
Our next speaker is R. Srinivasan, but unfortunately he has conveyed regret because he's not well and he's visiting a doctor. So he said anyway he will try to join as soon as possible, but we can wait for a few more kind of some half an hour or something. Otherwise, meanwhile we'll go ahead with the next presentation. Next presenter is Sarojini Maurya from National Institute of Ocean Technology. She will present her work on development of autonomous underwater profiling drifter. So Sarojini, are you there?
Yes.
Very good. You can share your you can share your screen presentation with us.
Yes, welcome, Ms. Sarojini. You make your presentation and uplink your slides, and your clock will be there. You can find to the timing.
Okay, sir. So is my presentation, you can see my presentation, sir? Hello?
Yes, we can see. Only there is a lag in your voice. Maybe you put off your video.
Okay, just a second, sir.
That will be helping us, yes. I'm also switching off my video. Please continue.
Just a second, sir. I'll just mute my video. I am unable to find the option where to stop that.
No problem. You continue. Your time is already running. You continue.
Okay. Okay, sir. So myself, Sarojini Maurya from National Institute of Ocean Technology, and I'm going to give presentation on development of autonomous profiling drifter. So before these, I am unable to change. Okay. So these are the outline of my presentation. I'll straight away go to the background. So before explaining about the development of our profiling drifter, I will just give a brief background. So few decades back, the ocean observation was being done using the Rosette technology. I have shared a picture here. So in which the people have to go to the ship and go to the desired location and deploy these Rosette and get the samples to get the data. So which involve lot of ship time, lot of manpower, and there were many limitations like in bad weather the samples could not be taken. So in around year 2000, profiling floats were developed, which is a revolutionary technology to sample the ocean. So many countries joined together to form an international program, which is called Argo International Program, in which more than 30 countries, they deploy these profiling floats in the world ocean to get the ocean data. So this, I start with this. So these profiling float, they profile up to 2000 meters of the depth in the ocean, and they measure the salinity and the temperature with respect to depth, and the data is relayed by the satellite communication and made publicly available to the public within an hour of the transmission. So these were the objective of this international program, like to document the seasonal to decadal data, and which help us to make our forecast model better. So India is also a part of this international Argo program, and it has the agenda to deploy and uphold 150 Argo floats in Indian Ocean. So in Kois, Hyderabad is the main hub from India, and NIOT has taken the indigenization of this technology as part of this program. So coming about the autonomous underwater profiling drifter, this is a free drifting profiler which measures the temperature and salinity of the upper 2000 meter of the ocean. And as the data is collected, it is transmitted, as I already told, and made publicly available within an hour. These floats are pre-programmed and operates on the battery. So these are fully autonomous, and these, it collects the data for a longer duration in ocean without any human intervention after the deployment. So these were the design requirements to meet the standard of that program. Like your float should be operational up to the depth of 2000 meter, and it should give minimum of 150 profiles. And because it will be unattended in the sea, so it has to be reliable, and because it has to work for longer duration, so your power consumption has to be minimal, and the data transmission with less losses. So this is an overview about the float, what we developed. It has an aluminum hull, and it carries a CTD sensor on the top cover of the float, and it has a satellite antenna. We use here the Argo satellite communication for the data telemetry. So coming to the working principle, how it profiles to the 2000 meter of operational depth, it changes its buoyancy, and which in turn it achieves the variable buoyancy by changing the volume, which it does by pumping an hydraulic oil from to an external bladder. So in this animation, you can see that the hydraulic oil is pumped to the external bladder. So the volume of the system becomes more, and it becomes positive buoyant. So when it has to sink, the oil goes inside the system and the volume becomes less, so it sinks to the parking depth. So this is the mission sequence what the float is programmed to follow. It starts from the surface, and then it reduces its volume to reach to the parking depth, where it has to meet a descent speed between 8 to 10 centimeter per second. And once reaching to the parking depth, it drifts there for a few days, and then again it increases its volume to ascend to the sea surface. Once reaching to the sea surface, it transmits the data to the satellite, from where it is received at the source station. So this is called one cycle, and the float is supposed to continue these cycles until the battery dies. So these are the major component of our float. The buoyancy engine is the main system which helps us to change the volume of the system, and these are the electronic system, which mainly I already said, the CTD sensor and the satellite communication system. The control electronics mainly include a 16-bit microcontroller, and of course, as we said, that it should be minimal power consumption. So we have idle mode and operational mode. So we keep most of the peripheral off when it is in idle mode to save the power. And again, this CTD sensor and the satellite transmitter is connected via the RS-232 protocol. And we also have a external memory for data storage. The software of the float has a two mode of operation: user mode and mission mode. In user mode, the user can interact with the system, and this can be only done on the deck or in the lab. So here we can set different parameters, check the functionality of the subcomponents. Whereas in mission mode, it does the buoyancy control, it does the sensor data acquisition and the data transmission. So once the float is developed, it has to go to the sets of qualification tests to make sure that it is reliable and functioning well in the sea. So pressure testing is done in our hyperbaric test facility, so that we make sure the float is working fine at 200 bar pressure. And ballasting is to trim the weight of the float properly so that it is neutrally buoyant at the parking depth. Volume testing is to make sure that the displacement of the displaced volume of the float is good enough to take it to the parking depth. And the post ballasting test is nothing but in a tank we try to simulate exactly the sea condition to do the final functionality test of the system. So this is the test setup of our which we had made to test our variable buoyancy engine, which is the main subcomponent of our float. So here is the pressure chamber in which the external bladder will be there, and then the buoyancy engine was tested for more than 50 cycles in this test setup, and the current consumption was also accounted, because a motor will be pumping the oil, which will get loaded when the pressure exceeded in the pressure chamber which the bladder is facing. So the current consumption was accounted during this test, and the reliability of the variable buoyancy engine was tested. So once the float qualified all the qualification tests, sea trial was planned in May 2013, and the float was deployed off Cochin in Arabian Sea, and it has given very promising results, and it has sustained more than 250 days in the ocean. So these are some set of data which we had got from the float. This data is from May to July. Of the temperature with respect to depth, and this is the salinity with respect to depth. And this is the trajectory which the float has, because as I said, this is a drifting profiler. So it drifts along with the current. So this is the trajectory what the float has followed during its lifetime in the ocean. So coming to the conclusion, the development of the AUPD was completed in NIOT, and the technology was demonstrated in Arabian Sea, and the performance was found satisfactory. The data sets were also sent to INCOIS for doing the proper data quality check as per the Argo standards, and we are happy to say that none of the profile had got a bad flag. And this technology is now transferred to industry for further production and manufacturing, and we have already started working on the profiler which can go even deeper, because now we say that the average depth of the ocean is around 4,000 meters. So, and this Argo program takes care of only half of the ocean. Now the oceanographer says that the deeper ocean is also they are also having now significant changes, and it needs an observation. So we have already started working on the deeper profiler which can profile up to 5,000 meters. And with this, I conclude my presentation. Thank you, sir.
Thank you very much. I think you are within the time. I think it was well presented. And any questions for her for this very informative and wonderful presentation on this important product which we have developed in India? Any questions, please?
Yeah, I think there are a couple of questions which have come. One is the same buoyancy pattern followed for Arabian Sea and Bay of Bengal? Is one question that is asked.
Okay, so actually we have done some study and found that in Bay of Bengal we have in some season this low salinity regions where when there are freshwater discharge. So of course the variable buoyancy engine will not be giving the same performance in those regions. So for that, we have already started our work, as I said, which needs more, the buoyancy engine needs more volume displacement to work in those kind of regions where the salinity gradient is high, or there is a freshwater discharge and where we have this low salinity region. So of course, the same float may not be working. That problem is there. That is why we have taken up another work with the higher capacity buoyancy engine.
Another, there is one very question is there by Dr. Ravichandran. What is the longest time the float worked by indigenized float?
So it has given the float which was first deployed by us in Arabian Sea had given 135 profiles, and that is like we were profiling once in 2 days, so that was around 270 days it has survived in ocean.
Fine. It is followed by a supplementary question. It goes this way: that is it possible to change the mission from 10 days to 20 days? Can you park the float at 1,000 meters, but profile up to 2,000 meters?
Yes, sir. These things can be achieved by customizing the mission parameter, and yes, it can be done.
That's
the
very
user
good.
is, yeah.
That's very good. I think that's all from the.
I have a
Yeah.
very one question. I think it's very interesting talk and very good development. Is there any possibility to add any other sensor, for example, biogeochemical sensor somebody wants to add? Is it possible to add in this?
Yes, sir. If the opportunity was given, we could have worked for that. But because once this float was the development was completed, we started working on the deeper float, in which we already have the option to add more sensor. But in this float also we can add the sensor, but accordingly the electronics need to be modified. But the options are there. We can add more sensor, but accordingly the weight adjustment we need to tune.
Very good. Good work. Thank you very much. Thanks for a very comprehensive presentation. Thank you.
Thank you.
Our next speaker will be Rajkumar. So essentially Rajkumar and Muhammad Nasif. So Muhammad Nasif will present. Both of them are from Coastal Environmental Engineering Group of NIOT. And Muhammad Nasif will talk about sensitivity analysis of wave hindcast for the design criteria for engineering applications. Muhammad.
Yes, welcome, Mr. Mohammed.
Yeah, thank you.
I'm sure that you are aware of the time constraint and very important topic you'll be talking about on wave hindcast, and in particular to the design criteria. This is what application of the environmental data, what we have collected, you'll be presenting on the design part of it. The floor is open. Kindly make your presentation.
Okay, sir. Respected Chairman, coordinators and delegates, good afternoon, everybody. I am Mohammed Nasif from National Institute of Ocean Technology, Chennai. Here I am going to present my work, sensitivity analysis of wave hindcast for the design criteria for engineering applications. For the introduction part, we accurate information about the wave characteristics of and climatology of a region is required for the accurate coastal and offshore activities, designing of coastal and offshore activities. We are we are know that third largest Indian Ocean is the third largest ocean with about 20% of water on the planet Earth is present in Indian Ocean, and Indian Ocean surface waves possess unique nature due to the prevailing wind conditions and geomorphological nature. Generally, 3 seasons are considered based on the monsoon activity at the monsoon activity or the region, like pre-monsoon season, monsoon season, and post-monsoon season. The right panel shows the previous studies based on soil probability from this is published by Samedo et al. 2011 and Chen et al. 2002. These are the we can see that the soil probability is very high in the northern Indian Ocean in 2 extreme season: December, January, February, and June, July, August months. The National Institute of Ocean Technology published a wave atlas version 1 in September 2014 with 15 years of wave simulation by numerical model Mike 21. It is used a high resolution wind forcing from ECMWF operational wind archive, and the main one of the main objective for the wave atlas was for estimating the design parameter for wave simulation using 22 years of simulation. Now, NIOT plan to release an updated version of atlas, plan to release including both Lakshadweep and Andaman Nicobar Islands. This sensitivity analysis I aimed for the selection of optimum southern boundary extension for the domain. The model domain with different southern boundary extension is selected for this sensitivity analysis, like 0 degree, 20 degree, and 40 degree, and 60 degree southern boundaries. This is the general wave climatology over the North Indian Ocean for annual average wave climatology, significant wave height, pre-monsoon season, monsoon season, and post-monsoon seasons. Generally, both pre and post-monsoon seasons, the wave climatology is very really calm during the seasons. But in during the monsoon seasons, due to the filature jet and cross-equatorial wind regimes, the wave height are more. Coming to the data and methodology, we used the third generation spectral wave model developed by Danish Hydraulic Institute, Denmark. The Micro21, we can use unstructured mesh with different grid resolution. Its grid is flexible grid, and the top portion is top figure is showing the model grid, and the model bathymetry used in this analysis is E-topo1 Micro21 digital C chart and shallow water bathymetry survey data from NIOT. The model is posed with a high resolution ECMWF operational archive with resolution of 0.1 degree resolution. The boundary conditions, two types of boundary conditions we used in this analysis. One is the open boundary and a closed boundary. In open boundary, instead of wind forcing with wind, we used the wave parameter like significant wave height and peak wave period, mean wave direction, and directional standard deviation. This data is used from the ERA 5 dataset from ECMWF. The analysis period is covering whole year 2017, and the two deep water location we are selected. One is in Arabian Sea, AD07, and one is in Bay of Bengal, Southern Bay of Bengal, BD14. The daily averages of wave parameter, significant wave height, wave period, and mean wave direction were selected for this analysis. Coming to the results, we estimated three statistical parameters like correlation coefficient, root mean square difference, and standard deviation. This results corresponds to Arabian Sea location for significant wave height. We can see that the correlation coefficient for different domains we selected here. OBS means observation, and different domain configuration. OP0S means open boundary at 0 degree boundary, and observation versus previous atlas version. And we can see that the correlation coefficients are very high for all domains. But during the pre-monsoon and post-monsoon season, the model performance is different for each domain configurations. But during the monsoon seasons, all domains are matching well with the observation. This may be due to the possibility of different swell wave height estimation capability, because during the monsoon season, the swell wave activity in the basin is suppressed by the monsoon winds. So the swell wave activity is more prominent during the post-monsoon and pre-monsoon seasons. This figure shows the same figure, but for clear view, I made separate separate time series for selected domains. Here the 60s closed boundary is matching well with observation, and the wave height during tropical cyclone Oki, which were present over the location during early December, December 2 to 6, I think. And this corresponding wave height are simulated equally on all domains, which means the capability of a tropical cyclone wave height is equal in all domains. But this configuration doesn't aim to simulate the tropical cyclone correctly. We have to modify the configuration for accurate estimation of tropical cyclones. Considering the statistics, the domain with 60 southern boundary is performing well. Coming to the next location at Bay of Bengal, the significant is presented here. The simulation performance is different for each domain. We can see that since there is no clear seasonal activity in that region, we can see that the model performance is different for all domains. Domain with 20 SA is performing well, followed by the 60 domain. While looking at the time series plot, the 60 SA is matching well with observations. And coming to the considering the correlation coefficient, a 2% of increase in the correlation coefficient for 60 is obtained compared to the previous atlas. Coming to the next wave parameter, mean wave period, the pattern is similar to the significant wave height. Both pre and post monsoon seasons, the capability is different for each domains. The correlation coefficient is maximum for the 60 degree domain, and RMSD and standard deviation also lower for the 60 domain. But the mean wave period is overestimating during the pre and post monsoon, non-monsoon seasons. Similarly for the Bay of Bengal region, mean wave period is presented here, and the closed 0 degree shows the negative correlation. Here is the negative correlation with respect to the observation, and open 0 degree shows the good correlation and the lowest RMSD, but the standard deviation is the highest. So consider the time series plot, the pattern, again the 60 degree AC is performing well. Coming to the model directional mean wave direction, all the model domains are performance is very poor performance and with negative correlations. Model with among the domains, model with 40 degrees is southeast open boundary is the best compared to others. Model with 60 is better than the old atlas, considering RMSD and standard deviations. For the Bay of Bengal region, it is same trend is seen here also, and the model with all domains have poor performance. And the model with 0 degree is closed, 0 degree closed boundary has highest correlation coefficient, but in the case of mean wave parameter, we see that the negative correlation is seen in 0 degree. So we have to the model direction discretization is currently 12. That means that resolution is 30 degree. That may be the reason for the poor performance for the direction simulation. So coming to the summary, model sensitivity analysis with the selection of model southern boundary are carried out. Model domains with different southern boundary extensions like 0, 20, and 40, 60 degree are selected. Both open and closed boundary scenarios were utilized for this analysis. The statistical parameter for intercomparison with Bowie data and the old version, waveless version 1 is presented. Since the NAO North Indian Ocean experience swells from Southern Ocean, model with 60 is performing well compared to the other domains. The model's directional discretization may be the reason for the poor mean wave direction comparisons. So we have to fine tune further in directional aspects. And these are the reference. Thank you.
Thank you very much. Very interesting application-oriented work, and you also correlated with data collected from the boy. Any questions for him, Dr. Prasad?
From YouTube, there are no questions. So no, just I want to ask one question, especially in the hindcast. Whenever there is an event which is, for example, a cyclone.
Yeah.
So it is occurrences cannot be predicted definitely when you are doing about not about hindcast, but in case of forecast.
Yeah.
So, but for a non-oceanographer, how you will explain that such events, at least on annual average basis, can be kind of I'll say modeled, not event as a single entity I'm trying to say, but its effect on the overall say wave climate, how it can be modeled in the let us say a long-term annual average forecast
for tropical cyclones.
Oh yeah, for tropical cyclones or any other disturbance.
Yeah, for tropical cyclones, we have for example in the case of Mike, we have another module for tropical cyclone simulations, which requires other parameters like wind pressure, atmospheric pressure, and data. So we have to reanalysis or assimilation.
Assimilation you have to do. Fine.
Very good. Well, I just have a simple question, like how your model is showing the difference between Arabian Sea and Bay of Bengal. You generalize the Northern Indian Ocean because we know that swell effect is more in Arabian Sea.
Where is yeah.
You have a long swell which is coming from Southern Ocean is more predominantly affecting the Arabian Sea.
Yeah, because Arabian Sea is we can see seasonal variation is very prominent in Arabian Sea.
Good, very good. If no more question, thank you very much. You have made a very good presentation. You could cover very well, and this is what is site-specific requirement for our country, and particularly on wave, considering all the futuristic activity of the structures to be installed. This work will be very important. Thank you.
Okay, thank you, sir.
Thanks a lot. And next, last speaker of the day and for the session, we have Mr. Muthukumaru. And I can introduce myself. He's a senior scientist working in the field of development of technology for aquaculture. Currently, he's working, and he has also developed on instrumentation and basically on ocean energy thermal conversion system, on power module part of it, electrical part of it. In fact, he had done a lot of work, and he is working as a senior scientist, National Institute of Ocean Technology. With this brief introduction, I request Mr. Muthukumaru to have his presentation for us. Thank you very much. Floor is open to you.
Thanks, sir. I am Muthukumaru. Thanks for the chairman to introduce me very well. And he's my boss also in earlier projects. So shall I start my screen, sir? Sharing.
Yeah, please uplink your presentation.
Yes, sir. Yes,
Please.
sir. Yeah. So you able to see, sir?
It is getting loaded. Yeah, we have to go for the function now. Another 15 minutes. We'll close this session. Thank you. Thank you.
So now you can able to see.
Yeah. Please proceed. Yes.
Sir. Actually, this my part is design development of atomic open sea submerged gauge system. Actually, presently our MBT, this is joint project between Ocean Electronics and MBT group. So presently our MBT group has developed this floating gauge, which now we are seeing there. So actually, this having some problem due to bad weather because the volume is reduced. The net coming to the surface due to the wave action as well as the current. So that since the volume of the net is reduced, so the fish is coming under so stress, and there are so much of damage. In order to avoid that, we need some rigid gauges so that volume will not.
Dr. Saurav, we are not seeing the timer.
Volume we can we will not reduce. So in that aspect, we are attempting. There are 2 or 3 different cases.
Yes.
So first, what we thought is whatever these floating gauges we can submerge to the desired almost 10 to 12 meter depth, so that that wave action and the current, the surface current will not be that much effect on the net which is floating on the floating gauge. So that we attempted by adding the buoyancy gauge. These are the parts which we have did. These are actually a prototype we have tried, and then it will be buoyancy control based on the some submersible pump and attaching the dead weight to the that buoyancy tank, and instrumentation dash to have the buoyancy control. Now to have this is the buoyancy weight, whatever the sizing the tank, because since the tank was sized with the MS, so because the MS weight itself density wise it will be more. So we need to adjust the thickness wise. At the same time, we need to have a reserve buoyancy of almost 1900, because there will be a biofouling, anticipating biofouling, and operational personnel standing on the gauge to overcome the what are the buoyancies coming. So all those things we have to taken care. So with this buoyancy control, to have the buoyancy control of the with the reserve buoyancy of 1900 tons. So with the 80% of water filled on the buoyancy tank, and it will submerge, and the controllable buoyancy will have we need to design for the 1900. That is a task we are given to us. So based on that, the different cases we did, and now we can, the last column you can see the 1900 net buoyancy based on the circumference of floating pipe, all those things. These are the weight of the component. These are buoyancy of this component, and then this is net weight. So for the case 1, so what it is, having the 90% of water and 300, if the 90% of water is 300 kg, and the resultant we have the 1908 upward buoyancy with the tank upward buoyancy is 2900. So this was also we did for the case 1. For the case 2, so that ballast tank furthermore we are increasing. So having the thickness, this thickness only the operation that is a sizing parameter to adjust the buoyancy. So if you have more thickness, in order to have, you will have the reserve buoyancy be killed. So optimum thickness we are sized for the 5. This is with the MS galvanized iron. But in the meanwhile, I have to highlight here our chairman also. I have during that time, chairman also gave the idea for the total tank will be sized with aluminum. It will allow further reserve buoyancy of almost twice this. So that is what he also told. But due to some financial this thing, and then some management problem, we are not able to do that. And so based on the thickness, this is a reserve buoyancy, we got it. And after that, so this is a, since the reserve buoyancy is not able to come in the because biofouling, all those things were coming in the picture, and within the one or 2 months, this tank and other things are getting biofold, and the reserve buoyancy was killed. So we are going for the next option of that is spur type. So that is what we have next to move on to that. Along with, since it is a submerged gauge, so we need to develop a feeder to go into the subsea level. That is almost 8 to 10 meter depth. So feed has to go to the depth. And similarly, at the same time, that the biomass also, we need fish biomass also, we need to be size, so that whether growth is, because if it is a floating gauge, so we can see the fish, and when physically we can see the growth of the fish. But in the submerged gauge, so either diver has to go, or engineer has to see some camera installed in the subsurface gauge, and then that we attempted, and then we could able to succeed in that, and this we patented the biomass also. So this is a scheme we have developed because it is hybrid gauge, hybrid type. Because since it is submerged gauge, both pneumatic, some case pneumatic is failure, so we can have hydraulic also. So we designed both by using the submerged pump installed in the, that is spur center spar, and you can buoyancy control we can implement. At the same time, in case submerged pump is failed, you can have the surface, from the surface you can have the pneumatic control, so that the water inside the spur will be pumped out. There will be a wall, controlled wall will be there on the outside of this thing, which can able to control, and then we can start you can select the hybrid, that is, we can select the pneumatic control to have the buoyancy control. So these are the two stability review on this, where CG and meta center also, how much it is sized, and then so that the stability of the gauge, we can see this. So the spar volume we have sized for the 109 liters. The volume of the spar gauge, it is 11 meter cube. This is a specification of it, which we have developed, and then with both buoyancy control having hybrid control, both hydraulic as well as pneumatic, with the 4-point mooring. With this we did in the Andaman North Bay Island, and then we could be able to keep the system live almost for 1 year. This is how it is that internal pipeline for the pneumatic as well as hydraulic control. We have this air inlet, and then water in and water out. This is for what we did. And what are the pressure level? So because due to for the pneumatic buoyancy control, we need to have the pressure control, for which these are the corresponding pressure measurement level, and the corresponding milliampere level. This is a test we did in the lab for the stability as well as the buoyancy control here itself for the ATF tank, for the from 0 to because we could be able to be, since it is we could be able to only the 3 meter only we were able to control. Then after that we did the trial at the North Bay, and then we could be able to see this functioning, ascending, descending almost 4 or 5 times, and then we leave the system for the 1 month. And finally we could the main problem not with the control, main problem with the biofouling was so much. So even then, since we have the reserve buoyancy, we have the cushion. So with that, even with the biofold was there, we could be able to achieve run the bio without any maintenance for almost 6 months. This is the subsea feeder which we developed And this is actually the whatever available in the source, whatever available the source in the washing itself. So that we are used for the feeder to operate the feeder, because self-sufficient feeder their size. Because normally the feeder, subsea feeder, whatever the around the world, they will be using pneumatic air from the barge. They will send the pneumatic compressor air or blower air to take it to convey the feed to the from the barge to or from the boat to wherever the location to the site. But that what we thought is very innovative idea. We thought is because since why unnecessary there is another payload for the compressor or blower we need to install, and power consumption will be more. So we thought of it using the same water available in the sea, that we can use as a medium for the conveying the feed. So in that way, the water ejector will be sized, and then this is the size we are. This is a novel NIOT size ejector, based on which this is the how the vacuum is created. Basically, it is this is the inlet of seawater going inside, and this is a feed inlet. So what it is, we have to convey the feed to the different for about 10 meter depth. So here we have we have the ejector orifice, so which will create some vacuum here. You can see the yellow. You can see here more velocity, and then we create a vacuum, and then it will suck feed from the tank, so that feed will be mixed with water, and it will go to the and the same as whatever the depth. So suppose we are keeping a 10 meter, so one bar will be one bar will be developed in the upstream bar. So that we have to overcome by this section head. So that we are sized, and then we could be able to succeed in that, overcome the section head, and then we could be able to achieve this. And because in the worldwide they could be able to achieve only the 4 meter, but NIOT has developed the ejector for the subsea feeder operation up to the 7 meter. This is a test we did, and this in the lab. Whatever the tank and the silo we are kept in the lab, and this is the boat we kept the silo, and then we send the feed. So this is operation feed of up to 6 meter, and boat level almost 1.5 meter. So 6 plus 1.5 or 7.5 meter we could be able to achieve this subsea feeder. Whereas in the world level they did up to 5 to 6 meter only. So this is a biofouling. What are the problem we faced? Biofouling, and then what are the buoyancy chamber? Also, it is a biofold. There was a kink. So this was we faced a problem. And this is a site where we installed the spot type gauge. So there is during the test we can able to we are satisfied with the hybrid control. Both the control we could be able to operate. So with the redundancy, and then only the biofouling we had some problem. So these are the components. So what were this? This is the pressure control. We have the pressure sensor. We kept it for the buoyancy control. This is a submersible pump for the another redundancy. We kept it, and spur bar. And in this is a center spar. We kept able to keep the submersible pump as well as for the buoyancy control. This is the external frame, and then the collecting frame. Thank you, sir. Any other? This is the thing. So we are now next we are moving to higher version of same rigid gauge for the almost 5 meter cube. So we are tender already, and this is geodesic shape. We are proceeding for that. Another type of submerged gauge. So this is a technology we are developing, and probably another 6 months we could be able to have one submerged gauge from NIOT.
Thank you, Mr. Muthukumari. Very interesting topic. NIOT started way back in 2002-3. A very simple lobster cage has evolved into such a high-level technology where it is required, considering the constraints we have in our conditions, particularly where there are cyclones. We need to have these cages to be protected. The stresses on the animals, also fishes, to be reduced. So these cages, what you have designed and demonstrated, will be of great help, having a societal implication. And you have also addressed very well on the practical implications of biofouling, which cannot be simulated in the laboratory condition. We started with the same phenomena in the first paper. We are concluding with the last paper with that. Dr. Prasad, any questions for him?
No, YouTube doesn't have any question. So, Saurabh.
Yeah, I have just one question. This is a nice presentation and so nice, very nice development. So I just want to know what is the maximum wave load and current it can bear.
Actually, we are actually we are next. This whatever the spur gauge we have developed almost 2 meter per the second. That is the current we are the size. So almost other next version we are developing, that is geodesic shapes submerged gauge, that we can have it on almost 3 to 4 meter per second current, and wave action almost to 2 to 3 meter.
Okay.
Very good.
And actually our profile, because there is a lot of actually the gauge culture was started by our present chairman, and actually now the Andaman North Bay, they are having very sophisticated locations and feasible for the submerged gauge. A series of submerged gauge you can put it, and there are some entrepreneur also, they wanted to have this. So that is a background of motivation to develop this technology. Actually, probably that way, in that way, as rightly said by chairman, it will have some societal benefit, especially for the island where like the North Bay locations, that will be very feasible.
Very good. I think we will conclude here because we have to go for the validity function. With this, I thank all the 4 speakers today. They have made a very good presentation and they have lived up to the expectation, and also with the time constraint given to them, with the vast topic and knowledge they have, they were able to convey the message, and all of them presented very well and direct application oriented, which using the data collected from the field or used in all the studies. With this, I thank once again, and I thank Dr. Mandal and Dr. Prasad for coordinating with me in conducting the session. I thank Osicon, the organizer, particularly the chairman and everyone, President of Osicon, for giving us this opportunity. With these few words, we conclude this session. If anything more to be added, I request Dr. Prasad and Dr. Mandal to say a few words. Thank you very much. Thank you, one and all.
Just one, Mr. Muthukumar, please send the copy of your presentation. I have received all other presentations.
Sir, I sent you, sir.
Oh,
Sir,
excellent.
I sent you.
Yeah.
I
Yeah,
already
sure.
sent you. Friday itself, not Friday.
Okay.
Day before yesterday, I sent actually.
Okay. Let me check once again because I did not receive. I'll talk to her. Fine. All right.
However, I'll say
Yeah, sure. Sure. Thank you so much.
Thank you.
Thank you, sir.
Thank you very much. Thanks to everyone.
Thank you.
Thanks.
Let us close the session. Thank you. Thank you, Dr. Mandal.
Thank you, sir.
Thank you, sir. Thank you, sir.